Hi everyone, and thanks for coming to the HBase Meetup 2026. We haven't do that for a while. I hope you guys still active and remember each other. And I saw the room from HubSpot. You have the Bloomberg guest as well. Thank you for coming on site. Viraj and everyone from Bloomberg and people from online. So how can I?
That's interesting.
Next slide. Right. So, yeah, I generate these things from AI thing, but looks like very good. So everyone let's learn each other's and see if we can build another generation of HBase together. I go through. There is a total of originally have 7 topics, but right now cut down 1 because another folks from the Australia app network cannot join, so he had an issue. So now I cut 1 presentation down, but what we have is each presentation will be about like 20 minutes. You can go a little bit further with QAs, and then we will have a discussions at the end. Sorry, this is the number 7. Sorry, not yet. All right, then maybe the first one is Shamuka. Talk about the replica deferment. Do you want to stand there or like see people? Yeah, you can come over. Yeah, but the share screen is the same. So you use the Zoom app to share the screen.
Hello everyone, I'm Shamuka. Oh, I'm muted.
You don't need to use your computer. So just speak a little bit louder. Yeah.
Okay. Hello everyone, I'm Shanmuka and I'm working with Cloudera. Today I'm presenting the feature Read Replica. So on a high level, I created this with AI again. So earlier, like if we had to do anything like high availability or scalable read workload, we had to use an active-active replication where we had to like duplicate the storage and set up the replication, and it included data migration, and that was not really cost efficient, and also we could not scale it as much as we want. But as part of this feature, we have a shared storage and we can spin up many HBase clusters, as many as we want, with 1 active cluster and many replicas. So that's the problem we're trying to address as part of this replica. So on a high level, the design and components, we need to tackle 5 different things. So one is the shared metadata. So we have many system tables, and we need to isolate the cluster specific tables. And that's the first part of it. And then we also introduced a new global read-only configuration, and how we change it to toggle the clusters between active and replicas. And another big problem is having multiple active clusters, and we have introduced another config to prevent having this situation, like a split brain situation, where we have many active clusters trying to write in the same storage. And manual synchronization commands, refresh meta and refresh H files. And we'll go through this one by one as we go. So the first one is we have all these system tables, ACL, namespace, quotas, RS, all these. Some of them can be shared. It wouldn't be much different if many replicas are using the same namespace or ACL tables, right? But meta table is very personal to the cluster, and it needs to be unique per cluster. So we have created this HBase meta table suffix. This can be added to the HBase site.xml, and having an appropriate value, we can isolate the directory in the storage. And for every replica cluster, we have a unique suffix that can be set. And the same applies to the master region as well. These are two table directories that today we have introduced this to. So we have like in storage, like HBase meta underscore, whatever the suffix, replica 1, replica 2. The same goes with the master region directory as well. So when the init meta procedure is run by hmaster, we run this initialization of this meta table name. Today it is static, but we have this in table name class where we read it from the configuration and set it at the creation of the cluster. So yeah, that's pretty much about the custom meta table. And moving on, this is like one of the main pillars of the read replicas, enabling the read-only configuration. So this is a Boolean value we have introduced as part of this feature. So it can be true when it's true, the cluster is global read-only. And when it's set to false, it's mostly it means it is like an active cluster. So we have used a coprocessor framework for implementing this, and we have introduced a new read-only controller. Well, HBase has many write paths, so we can do a bulk load, we can do write with client API or anything, right? So introducing basically we have to intercept all these write paths whenever a write happens to check if the cluster is if the write should be allowed for that cluster. So we have all these, we have split the read-only controller into all these 5 different subclasses where we have methods to block the write action. And we have like mapped all these controllers to wherever the writes are coming from. But another thing is, even when the read-only is enabled, we should still be able to write into certain system tables. So that is still allowed because some system like metatable and all, they are very cluster specific. So we need to be able to write into those. So so this is how the coprocessor framework has been extended for this feature. And we can toggle the cluster by changing this variable at any time and using the update config methods. So so we have all these update all config or rs group config or update config like commands today. So when this property is changed in HBase site.xml, the flow is usually you enable the global read-only, it puts the cluster in read-only, and you shouldn't be able to do anything, right? And if you try to basically switch, you just have to change it and update the configs, and you should be good to go. And all the writes will be blocked with the do not retry exception. So that's how we can change without having to restart. So that's another major feature we have. And this is a second pillar, I would call it. So most of the times, maybe it could be user error or any of the system undesired behaviors can happen all the time. So in any of those cases, we shouldn't have multiple active clusters writing into the same storage. That would be not desirable. So so we need a mechanism to make sure that we always have only one active cluster. So we have introduced this file, active cluster suffix ID file, that stays inside the shared storage. And it contains the cluster ID of the current active cluster, whatever it is. So this file is basically readable and accessible by all the clusters, and readable. And there are 2 scenarios to consider here. So when at startup, the file is already existing, and the cluster that is starting is the owner of the file. It would check the content of it. It would see, okay, this is my cluster ID, and it would start as an active cluster, and that means the read-only is set to false. That is an active cluster. But you have read replica or any other cluster trying to start an active mode, and it would find this file, say, okay, this is not my file, and then it would check the read-only. If it is a read replica cluster, it shouldn't be able to start. So we run into an exception scenario. And then when we are switching, right? So when an active cluster is moving to the read-only mode, right? So it would actively delete the file, its own file. So it should be able to delete the active cluster ID file that it created, and it would move into read-only. And when the read replica is trying to become an active, it would check and make sure the file doesn't exist, and then it would create its own active cluster suffix. So we always make sure that there's only one file in this in the system, and the content of it is like we are implementing it using the protobuf, and we always make sure there's only one active cluster. So that's the main idea behind it. And moving on, these are two new commands that are introduced as part of this feature. One is refresh meta and refresh h files. So, so we need synchronization between two clusters at two different levels. So what refresh meta does is it basically just picks up the new files, like new tables, new regions, whatever happened to the meta table. So maybe a region was split, or the table was deleted, or new tables created. Any kind of region boundary changes, all those are, whatever changes go into the meta table would actually be picked up. How do we do this? So we consider the shared storage, the underlying storage, as a source of truth. So, so what we do, we've implemented this as a master procedure. So what we do is we have like an in-memory view of the current metatable, and then we have the storage. We scan through the directories and pick up whatever is new, and then we use the metatable accessor to just insert these values into or update the current metatable and apply all the mutations that we've actually calculated based on the current storage, like whatever directories, right? So we need to run this every time, like we want to synchronize the cluster. And another, the next command that we need to run is refresh h files. So that is more for the changes that happen to h files, like the region server and all the region hosts and all the stores that belong to the region would have changed. So if there was a compaction that was run, like maybe anything that happened in the underlying storage, the replica cluster would never know if you don't run this. The region servers would like still pick up, probably be looking for folder store files. So we need to refresh the in-memory view. We need to load those new H files into the memory. And for this as well, we have used procedure framework. And so the client like submits this refresh H files, and then it goes to the master, and master sends the broadcast to all the region servers affected, and they would go to the regions and reload all the store files. Already like refresh store files method on each store. So this basically completes our synchronization process. And at this point, we can basically say active and replica clusters are in sync unless something happened already during this process on the like active cluster. So yeah, so the configurations and commands are summarized here, and refresh H files has multiple variants to it. So we can do it for a table, you can do it for namespace or particular table in a namespace. And this is just like a consolidated view of what we have and the default values of all the configurations that we've added. And where do we use it? So as we already talked about, like there's no need for data migration, duplication, and there's no limit like on how many replica clusters can be created. So it could technically be infinite, but of course. And like you could do a workload segregation. One important thing to note here is this is eventually consistent. So we might not be able to see like the most recent writes happening into the cluster. So that's one like trade-off that we have, right, with this design. And we need to do manual refresh until sync. Sometimes like when the active cluster is still like very active. And so that would still like need manual synchronization. We have still not implemented that one part, but yeah, so those are two things to be noted. And that basically summarizes the feature on a high level. If you want more references, we have the design doc, the Jira, and the demo. I would like to call out one thing here. We're trying to test this feature, and right now the meta table name it's static, right? So if you remember the custom meta table name part, like I mentioned, we have like this entire process to be static. So kind of testing this would be like a problem, like because we cannot spin up HBase clusters and modify one static variable. So we are trying to address that as well, like trying to move into non-static meta table name. That effort is in progress. So there's still like some work happening on that, but this on a high level summarizes this feature, and I'm open for questions.
We have some questions from Slido. First one, is this the same feature that AWS provides in EMR?
Yes, we have like taken this off the blog post, the AWS blog post. So this is the design doc, and this is the blog post that AWS has, and we are trying to base this off the, I mean, very similar to this. Yes.
Cool. Next question. How do you handle the race condition when two active clusters are trying to start at the same time?
Right now, like we have like a locking mechanism, like whoever tries to create the first active cluster suffix, and also we don't create two active clusters like at the same time. We happen that's more like on the user, but core level, if you try to create both of them at the same time, I think you will run into whoever gets the lock first, I guess.
Cool. Third one, final one for Slido. How do you handle configuration mismatches? For example, one region server is in read-only mode and the other is in read-write.
Yeah, we have actually like considered that in design doc, but it would be yeah, it would lead to inconsistencies. So the HBase site.xml should always be updated, and the config should always match. But if it would be changed at one region server level, I think that is blocked. The global read-only mode would not be set, I guess.
I have another one, which is for the refresh H files. If there's a very large clusters with many tables, so when you hit that, what will the overall like progress looks like? You show anything, and if it's running too long, like, do you know about it?
Yeah. So we have like we create sub procedures for every region. So if we have many tables, and every table has like really large number of H files as well. So each of them would be handled in a sub procedure, and procedure class itself has a timeout.
Yes.
So if it goes beyond that, the procedure itself times out. So, but whatever has been refreshed, I think we can still adjust if you want timeout for the procedures if we are expecting a lot of data. So that depends mostly on the limits on the procedure class side.
Cool.
We have an additional question for refresh H files.
It's me.
Oh, that was you. Sorry.
I have one question. So, what does the shared storage looks like from the file system perspective? Is it like is it going to have like cluster ones, like cluster one / table / regions, and the cluster two / something, or is it?
I can show it. I have like it here. So this is how it usually. Sorry, let me pause this. Okay, so it's the root directory. We have the active cluster suffix file. Okay, we have the active cluster suffix file, and if you can see, HBase has two different meta table directories. If we have more, we'll have more subdirectories under HBase. Yeah, this is, and master data is the master region store. Sorry.
Got it.
Yeah, this is how it will look.
I apologize, I missed the beginning of this presentation. It looks like it's a read replica and it's implemented in a very interesting way. So you have a shared storage and you have several HBase cluster which work on top of this shared storage. What do you expect from this architecture? What are benefits do you expect to get? Is it improve the read performance, or is it kind of improve high availability?
Recording in progress.
See what's
Sorry.
All right.
We're good.
Yeah, so it's to address high availability and also we can have many read replicas to improve the read performance. Also, we can deploy these replicas in different AZs that also would contribute to high availability. And we also have, we could do this for probably like blue-green deployment, where we want to test the read performance and then you want a new cluster instead of spinning up the entire thing. You could just like spin up the cluster. So there are many use cases for this feature.
Let me also share the customer scenario that we faced with, and that was the original intention, I believe, to implement this feature, was that one of our customers wanted to had a strange security policy that they have to refresh the AWS instances every so often, like every 2 weeks or every month, or something like that. And we provided a few options, like spinning up the new cluster, using replication to move the data and shut down the old one, or just do a switch, do a refresh on each of every instance, but they will lose the cache. So there was a many downsides. This one can be used to create or run the two clusters side by side. And one of them is active one, which is being written. The other one is the standby cluster. And then they're going to switch over. They can turn the active cluster into read-only and switch to the other one without moving the data, actually. So they actually save some money as well in storage. And unfortunately, as Shanmuka mentioned, this is completely manual to refresh at this point of the development. So there's no automated mechanism. So it's usually only useful when the writer workload is very little.
I think that could be improved by two things. One, of course, using Chrome job, but the other one is if we have some accumulate data, like a hint, X amount of records have been changed, whatever, then you can trigger that refresh.
Yeah, we can. Once this feature is open source, the plan is to keep on working on it and improve it with new features like the automated synchronization of like jobs that you mentioned.
Yep.
It's open for ideas, basically. Yep.
We also have this added in the design doc. Like we are considering like the metatable replication, like directly reading from the storage, right? So we could trigger like the event as soon as we notice that metatable, like the main HBase meta has been changed, or the active cluster, whoever it is. has been changed. So we are still considering options for it. This would be like the phase 2.
In this design, do we have like 2 separate zookeepers for standby? So how does the client know which one to connect to for the writes? Because the cluster can change anytime from active to read mode, and another cluster can become active, right? So the client which is connected to, like whether we use zookeeper or you use master registry or RPC registry, you are connected to one cluster, but how can it switch over to another whenever the active the cluster, like, goes from active to read only mode and someone else takes over?
That depends like on what workload, like what the client is doing, right? If it's performing active writes and you switch time, like then that would be a problem. You would have to like, I mean, if the user is running like a workload and wants to switch over, he needs to be aware that the cluster is switched on. Unless like if you're switching to a different read replica, that would be a different thing. But active to replica, I think the workload needs to be managed. Like we need to get it from the new cluster.
Yeah.
Currently, there is no plan for automated configuration, so it's hard coded in the client. So you have to reconfigure each of the client to connect to the other cluster. But I think there's already a feature, Cloudera downstream. I'm not sure if you're planning to open source it, but hopefully yes, which called the multi-cluster client, which each of every client has multiple cluster configurations, and they try to connect one of them to the active one. And if they experience some errors or under some conditions, they can automatically switch over to the other one.
The reason I ask this is because we have the same problem, and we are also like coming up with HA architecture, where we have 2 clusters and the client is same now, but it needs to connect to either one of them, right? So this is happening at the Phoenix level rather than HBase level. So at Phoenix level, we are coming up with, I mean, that this feature will also be open source soon, is that there is this cluster role record, which can be either in Zookeeper or in the HMaster or in the region servers, and client will be notified, like they need to get the cluster role record to know if this is an active or standby cluster, and then they can, switch over the writes from here to over there. So it's like for the failover scenarios where you don't have to worry about something like multi-cluster client. Cool. So we already used it in production once for a failover scenario where we had to like completely get rid of one cluster and bring up another one because the underlying architecture was changing, like from Kerberos to service mesh. Mm-hmm. And we plan to continue using this like for more clusters.
Is it already in open source HBase?
It's in Phoenix open source.
Okay. That's interesting. Yeah,
it's like Phoenix client comes. So Phoenix client uses HBase client, and then it eventually connects to HBase server. But then on the server side also we have Phoenix coprocs. So yeah,
gotcha.
So, no problem. Last question. I'm pretty sure that you consider the standard approach of the data replication, which is basically sending the wall edits from one cluster to another cluster and applying these wall edits on the cluster, which is a standby one. Why did you didn't go this way? So why did you decide that it's probably not worth implementing?
Because you don't want to do any duplication in the data. You don't want to.
High availability, you have to duplicate the data, otherwise you won't get the high availability. I'm saying because the major problem, even for the cloud providers, that from time to time, even AWS, some regions goes down, and if your cluster is storage subsystem, at least inside this region, so you actually lose all the availability completely, for some time at least. So by standard approach, by setting the several clusters in different regions and set up the replication between this cluster, which actually definitely results in the data duplication. That's the standard approach.
Yeah, I agree completely. So for high availability, that would be the ideal situation. But given it's mainly from the cloud storages, so S3 in theory is already high available, so you don't necessarily need to duplicate your data if you want to save some money.
Oh, okay. So I just missed this part. So it's basically for cloud-based deployment. Yeah.
Yeah.
All right. Any more questions? Just some basic clarification from me on the shared storage model. So when the H files on the storage is shared between two HBase clusters. Is that correct?
Yes.
Okay, right. And then in terms of deployment, so like the root directories are the same for both HBase clusters. And then they have the different, at least for Zookeeper, they will have different Z nodes for the meta storage. Okay.
They have two separate or more separate Zookeeper clusters. Zookeeper data is completely separate. And the ID, the cluster ID is the UID, which is the standard HBase ID file has, is the same for all clusters. We just only added the suffix string. So the entire ID consists of the cluster ID and the replica suffix. And that's what is stored in a separate file, but the same concept, that's the cluster ID file. But Duo is questioning this approach. So it's once we have a pull request and start the review process, he might have some other approaches. He mentioned we should store the meta table name in the master region instead of just reading directly from the configuration. So it's still under negotiation. But at least that's the approach.
Do we have any more questions?
Let me check Slido. I didn't see any last time. Yeah, we're good on Slido. Any final questions? Okay, cool.
Thank you.
Thank you, Shamuka.
Yeah, thank you. Yeah.
Thank you.
I don't know who's next.
Hey, I believe I'm next.
Oh, you're next? Okay.
Yeah. Can everyone hear me okay?
Yes. I can hear, yeah.
Awesome.
You probably need to click share. Yeah, thank you.
Yeah. My name is Charles Connell. I work at HubSpot on our HBase team. And I'm talking today about reducing garbage collection in our region servers. So first I'm going to kind of skip to the payoff. This is the allocation rate in a region server in one of our high traffic clusters before and after the change. So it's several 100% improvement. So how do we get there? Backing up, so HubSpot is marketing and sales software offered as a web-based product. Most of the information that our customers store in HubSpot ends up in HBase. We have 380 HBase clusters in production, and they're the high performance ones are on I8G 4x large instances in AWS. So as part of my job, I look at a lot of CPU profiles from Async Profiler. And so I'm going to walk through 3 different CPU time profiles that were taken from our production servers in 2024 and 2025. And so I'm just going to open those up here. Here's number 1. And we'll be getting more into them. Here's number 2. And here's number 3. And so in all of these, I'm looking at the block read path, and that's a very hot path in these profiles, sometimes because of a high request rate, and sometimes because of compactions. And what I noticed was that in each profile, there's this yellow blob of stack frames. Here it is in 1, or number 3. Here it is in number 2. And here it is in number 1. I'll zoom in on that. So the yellow blob is memory allocation. It's memory allocation. The allocator is being called by user code, and that's an allocation stall. And allocation stalls slow down your request if it's in the request handling path and just use up CPU profile or CPU cycles you'd rather not be using. So I was thinking about, well, what can we do about this? And so I like to think about, well, okay, what are we trying to do? And how does the way that we're doing it differ from what is theoretically possible? So what we're trying to do here is we're trying to decompress some blob of bytes. And in the case at HubSpot, we were trying to decompress them with zstandard. So what memory do you actually need to allocate to decompress with zstandard? You need to allocate a byte buffer that holds the compressed bytes, and you need to allocate a byte buffer that holds the decompressed bytes. And maybe the decompression algorithm itself needs to allocate temporary buffers, but those will be handled by the zstandard C library, so that's not going to show up as a Java allocation. So I looked at the code around these allocations, and what I found was that these allocations do not correspond to the source buffer or the destination buffer. And so, therefore, there are things that aren't strictly necessary. So, diving more into this first one, the HBase developers know the importance of reusing objects in decompression because it's a hot code path. And so there's a codec.
I don't have some issue. Like, I don't know
It could
why.
be our speaker, but
Yeah, can anyone hear correctly, like clearly? Can you try again, Charles?
Yeah, I can hear.
I'm switching microphones.
I can hear fine. Yeah.
So where was I?
Oh, it's still bad.
Can we turn it on?
Looking at
You still can't hear me?
no.
We can hear you, at least
Microphones?
remotes can hear you, I guess. Yeah. Coming through loud and clear on the call.
It might be.
Okay.
Okay. You just ask.
Rejoin the room.
Yeah, it will do that.
So I was looking at what was I saying? Where these allocations are coming from. They're not coming from the byte buffers that are necessary for the source or destination buffer. HBase has a codec pool that reuses codec objects so that we don't have to allocate a new codec object every time we decompress a block. And so in this code path here that triggers an allocation, the caller is borrowing a codec from the codec pool. And in order to do that, we have to allocate an iterator from a hash map. And that's a little silly. The point of using a codec pool is so you don't have to allocate. So if you are allocating to use a codec pool, you're not getting the real benefit from it. So what can we do? Well, we can replace this hash map and hash set with a, in this case, tree set. Because for a tree set, you can call poll on it, and you can get the first element removed without doing any allocation. So that allocation goes away. In number 2 here, still borrowing from the codec pool, we're doing an allocation in order to update a Guava local cache with some values that get referenced when running unit tests. So we don't need to run that in production. So I put that behind a Boolean, and now that's just shut off unless you're running a unit test. And this last one ended up being the biggest source of savings. Decompression was done via a buffered input stream. So for every block decompressed, there was a new input stream allocated, which includes the byte array that becomes the buffer for the buffered input stream. And obviously input streams can be useful, but do we really need an input stream here? We know that the compressed data that we're getting is in a byte buff. We know that the decompressed data is going into a byte buff. And also the Z-standard Java wrapper accepts byte buffs to its API. So no, we don't need an input stream. We can just pass the byte buffs, source and destination, straight to Z-standard. So solution here was I wrote a new code path that I'm sort of calling the fast path that passes data directly from the source byte buff to Z-standard and then points Z-standard at the destination buffer. The patch is too large to go through here. And so this new code path will apply to any codec that implements the byte buff decompressor interface, which right now is only Z-standard codec, but it wouldn't be too hard to add that to other codecs. So like I said, deploying these 3 changes, we saw a huge drop in allocation rates. And looking at the charts on the left half of the screen, we also see a huge drop in allocation stalls. And so these allocation stalls, in some cases, are latency directly added to a request. So hundreds of milliseconds on some of these requests that go away. And when we reduce the allocation rate, we also get additional second order benefits. So if we're doing less allocations, we need to do less garbage collection. And so even when the garbage collector is running in the background and not incurring an allocation stall, it's still eating up CPU cycles that could be doing something more useful potentially. So freeing up the garbage collector means more CPU cycles to work on requests. And the last thing I'll show you, this is a profile from the same cluster that I took about a month ago with these fixes in place. And looking at the decompression paths, you can see that the CPU time is dominated by the Z-standard C library in this case. So this is a success because this means that the Java overhead is gone and our CPU can focus on the actual decompression algorithm. So if you'd like to see some of those benefits in your HBase cluster, you can upgrade to HBase 263 or later. You can switch to the Z-standard codec, specifically the one named ZSTD codec. There's another one named Z-standard codec, which is different. Or you can implement the byte buff decompressor interface for a different codec. Before I go to questions, if there's any, this page has a summary of what I've talked about and also a few other allocations I was able to remove from HBase and links to all the patches that you can read more in detail about if you like. Any questions?
I have a question, Charles. Can you hear me?
Yep.
So you were saying this is only the use of this interface is only used in Z standard. Is there a Jira open at least for adding this to the others?
There is not. I wasn't sure, what the appetite was for kind of doing these sort of speculative improvements because I don't really have the infrastructure to do a good performance test of the different codecs. So I would be sort of guessing at whether this was an improvement. And I didn't want to do that.
Yeah, I mean, I think I would have an interest in trying this. I agree that there would need to be some attention paid. At least micro benchmarking would be, mandatory, if not perhaps sufficient. Anyway, I could take a stab at this.
Cool.
Yeah.
Any other questions?
Yes. Do you consider trying dictionary-based compression?
We have not tried that at HubSpot. That is supported today. It was supported prior to my work. You can feed a dictionary to Z-standard and use it, but I haven't felt like our data at HubSpot is in a great shape to build a dictionary off of, because we would probably need to build a different dictionary for every one of our HBase tables, I think, for it to be like useful. And that's quite a lot of work to bite off. So we haven't done that.
I think that it's even worse than that, and that if your data distributions shift in your table over time, you'll need to retrain that dictionary. And how do you know when to do that? I mean, there's a lot of infrastructure that you would have to build, maybe for marginal returns. I remember into
Depends
the
on the data, definitely. So some data actually allows you to get very significant saving additional, but others data, especially, it's just some kind of numeric and poorly compressible. Having dictionary won't get you anything actually substantial. As for data shape actually changing over time. So yes, it's not a very trivial problem, but it's definitely solvable as well. You just control your KPI related to the current efficiency of the compression codec with the dictionary, and if it drops below some thresholds, you just start retraining dictionary. Yeah, I agree. It's kind of tricky and complex. It probably makes sense if you can prove that adding dictionary to your compression scheme actually will save you at least 30-40% of the storage.
Yeah, that's what I was thinking as well.
It's, by the way, done in the open source project, which is called Carrot Cache. And it's a caching library in Java, which uses the standard with the dictionary, and it changes the dictionary dynamically by monitoring the compression efficiency. Yeah.
And I've looked at Carrot Cache, and I'm pretty excited about it, and haven't gotten the green light to set it up here, but it's right. It's an ergonomic use of a dictionary because it takes care of it for you. Yeah.
I have another question. So like for this improvement GC, are you guys using JDK 17 as well?
We're using 21. That's a very good question. I should have mentioned that. We're using 21 with generational ZGC.
Got it. Right. So if no more question, then we move on to the next one. Or if you still have questions, just put on the side, or we can discuss it again. Next one is and/or point in time recovery.
My turn. Let me share my screen.
Good.
Okay. So I'm Endor Monar. I I'd like to talk about another feature that Cloudera is working on for the continuous backup and point-in-time recovery. And so the current backup solution for HBase has some caveats. So incremental backup happens in batches, not continuously. If you want to back up more often, you have to run your incrementals more often manually. There's no automatic mechanism in that. The write-ahead log management is difficult because if you are behind with the incrementals, the wall files can grow large on the source cluster. Restore is only possible to last backup points when did your incrementals. So we want to allow users to restore data to any point in time, basically within a configurable window. I think by default it's 30 days. Enable continuous backup of wall files, wall entries, and reduce the data loss risk after accidental writes, deletes, or cluster fails. So when we would use it, we get basically anything where backups comes important. So accidental data corruption, deletion, disaster recovery, only for a cross-region, cross-cluster backup to an object store. So why is it needed? We want to reduce the recovery point objective, which is a maximum acceptable data loss, and the recovery time objective, maximum acceptable time to restore, to ensure the availability of consistent backup without manual intervention. So this is completely automated by HBase itself. What's the solution? It's built into the standard HBase backup solution. So when you initiate the backup, and you basically create a full snapshot, move it to the potentially a cloud storage, and enables the continuous wall streaming. Continuous backup replication endpoint is the new class, which is actually responsible for streaming the wall entries. Restore is basically restores from the snapshots, restores from the incrementals, and replay the wall files until to the time that you want to restore, the point in time that you want to restore. We implement the optimization of so we continuously streaming the wall files, and the incremental command works for continuous as well, which will convert the wall files into H files for faster restore. As I mentioned previously, the window of keeping the wall entries is 30 days by default. So it's built into the standard HBase backup commands. You create a full backup at the beginning and enable with a switch the continuous part. And you also can periodically run the incrementals to optimize the RTU. When you restore, you use a new command, PITR, and you set up what date time would you like to restore back to. The HBase automatically purge the old walls and the snapshots which are not needed anymore. So how the architecture looks like, I mentioned that this is primary for the public cloud installations. So for instance, we have an S3 storage on the right-hand side. So the continuous backup replication endpoint streams the wall entries and copies the barcode files from the region service. So when you initiate the backup command, it creates an initial snapshot, copies it to the S3, and at the same time starts the replication endpoint to stream the wall entries and copy the barcode files. When you do your incrementals, you have a bunch of wall entries already transferred to S3, which reads by the wall player, and we write H files, which can later be restored more quicker than going through all the wall entries. So when restore runs, it restores from the snapshot. It barcodes the incrementals up to the point where it's behind the point in time that you want to restore to, and replace the remaining wall entries by the wallpaper in the user table. So to wrap up, this will minimize the downtime with fast and flexible recovery. Depends on how often we run your incrementals. avoid the data loss, minimize the data loss actually, because there is some time to transfer the vulnerability. So obviously you will disaster, you will lose some data, but we're trying to minimize it by continuously backing up the vulnerabilities. This enables cross-cluster, cross-region backup storage into cloud providers. And you can just use the simple CLI commands that you already used in your backup solution. I also added some references. We have a design document for this, and then I also added an AppSim ticket for reference. We have the demo, which it's quite long and recorded at the beginning of the deployment, the development. But if you are interested, feel free to watch it offline. And I like to talk about one more thing. What's the biggest challenge in order to deliver a feature upstream is to get reviews from the community. So I like to draw attention to two separate pull requests which are being reviewed currently upstream. The bottom one is the main one, is basically feature, the big merge request of the feature. And the other one is the one which was created by a recommendation or a review feedback by Duo. So basically, he requested originally we didn't want to change anything in the replication framework or HBase, just build a new feature on top of it. But Duo suggested a better way of handling the streams, because one important thing is in the cloud storage that when you basically writing a file, although Hadoop supports it, S3, for example, you cannot sync or cannot flush your data. Only option is to close the S3 stream and leave it there. You cannot reopen it for writing. So we are unable to, when we deliver, because this solution is based on replication framework, we cannot tell the source shipper that we successfully persisted the data that we ship to S3 because we cannot sync, we cannot flush the file. So what we do instead, and that was Duo's idea, to set up the replication source shipper on a time constraint, on a size constraint of how many voluntaries have been transferred already, and synchronize with the stream that we are writing. So the replication source shipper, instead of the endpoint initiating the pointers to be persisted by HBase, the replication source shipper knows about that, hey, we are at the point where we need to persist the position and make sure that the data is written to the target, and notifies the endpoint that, hey, this is the time that you should close your stream and open a new one. So this is pretty important, and this is a requirement that's currently being reviewed by the community. So I'd like to ask all of you to take a look at and help us deliver the feature. Yeah, that's basically about it.
Thank you, Ando. Any questions so far? Let me see. Let me see here. So I have one. So for the continuous backup, for the wall replications that you guys have done so far, we currently only support to the same storage type, or do you support different storage type as well?
Any storage type is supported, which is supported by Hadoop. Okay. So it's
can
using the standard Hadoop file system, basically. It's primarily targeted for cloud storage, but you can use any Hadoop support file system as the target.
So if I do HDFS setup and then replicate to the cloud storage or any of them, Azure, S3, or GCP, that is okay.
Yeah, that's correct. And this, if I have mentioned already, it's important because it's targeted for the cloud storage, and this lack of the synchronization feature of the file system, it's already prepared for that. So you can, unfortunately, it's not able to take advantage. So if you define a target file system which supports sync, that's not implemented in the endpoint. So it's still working with the shipper to control how much data to deliver before closing the stream.
I got a user question, maybe different point of view is the restore point. So incremental backup basically is just restore the snapshots, right? And then Delta. For us, we will have this restore command, given a timestamp to whatever you want to restore to.
Yeah, within the window, a time window when we keep the WAL files back. So
How did they find out that time window at the beginning?
how HBase find out that?
Which is as a user. Yeah. So basically, like the WAL have been synced X amount of time, but then what is the latest things I can recover? The time window.
It's configurable.
Okay.
So it's 30 days by default.
Okay.
And you can, I think, you cannot query that. There is no command for that. What was the time?
Yeah, I was thinking
when you run the
about-
command, it will be validated that actually you can restore to that point for now.
So the query part is not there, but you need to configure yourself. Is that what it is?
Yeah.
So the restore will have to replay all the WAL files in that duration.
Yeah.
And
So it starts with the snapshot. And if you have incrementals, you have a bunch of H files to workload. And if it's within the time window, it will take advantage of the incrementals. But up on the top of this, the WAL player will replay the WAL entries which are in your time frame.
For the incremental backup, right, when we keep the H files, does it mean that we will have to retain the delete markers and old versions of all the cells, of all the rows in that duration, so that, even if the major compaction happens, we don't remove for the purpose of
We copy, so when the snapshot copies the data to S3, the incrementals creates the H files on the cloud storage.
Okay.
So there's nothing, and even the workload files, which are workloaded in HBase, are copied to the target locations. Don't need to retain anything in your HBase.
I see. Okay. Got it.
You want to clean it up.
I think his concern is like the size of the snapshot with the marker are large. Is that what it is?
Yeah, it could be depending on the.
So we don't actually pre-filter out those things when we. I think we use the same logic for snapshot, so nothing changed of that part.
Yeah, correct.
Yeah.
Can you guys hear me?
Yeah.
Yeah. Question about the intention of these of storing the WALs in a backup store is essentially to get like a point in time restore, essentially, right? Is there a recommendation as to how long back you need to store these WALs for? Because I'm assuming that it's going to actually increase the amount of storage on the backup side, because you're going to store essentially full backups plus the incrementals, and are going to also store the WALs in a backup store.
Yeah, that's good. What was the question? Sorry.
So is there a recommendation as to for how long would you keep these WALs in the backup store?
In terms of size or cost of the storage?
In terms of duration, I would say, because I'm assuming that once you have the incrementals, then you actually have the point in time that you would want to recover to, but the WALs would give you more granular recovery, point in time recovery, and that I think that is the advantage of this approach.
Yeah, I think.
Right, but then you probably want to just keep it till the last incremental was taken, right? Is there a need for us to keep it beyond that?
I think that makes sense. I haven't thought about it, to be honest, but maybe it could. Well, it depends on your use case, I think. It might make sense to keep more WALs than creating your incrementals, because you want to optimize. Well, actually, you will keep the WAL files anyway, so creating incrementals doesn't save you space in that sense. So it's probably the answer is not, but I'm not sure about that. I need to think about it.
Okay.
I think it's still based on the total data size, more or less is similar. And recommendation of how long right now is like I remember is based on configurations, right? So how many days or how many hours that you want to config in milliseconds anyway. But then Yeah, there's no recommendation, right, at this point.
Yeah.
Yeah, like
Actually doing you. I'm sorry.
maybe a capacity planning guide, right? Like there's like none yet at this point.
What capacity are you trying to refer, like storage?
Yes, yes.
And the main reason you are running incrementals is to make your restore process faster.
I think they have the storage capacity concern.
Right, like so I would have
amount
to
of
plan
days.
my full, and then I have to plan how much incrementals I have, right? Depending on how much my retention is, then like I have to plan the corresponding capital to have storage for it.
I think you make a good point. Maybe is like other than just based on the time, we should also keep tracking of how many space the wall has been using up to X amount of threshold. Then you have that one to be a secondary like criteria to say maybe have to show up as a recommendation of you should have another snapshots. Keep the size of the volume smaller or whatever.
Got it. Yeah, makes sense.
Right.
What are the various stores that you can write to? Currently, is it only AWS like S3 compliant stores that would be compatible, or would they?
It can write to any storage that is supported in Hadoop. So it's using the standard HDFS file system, object HBase. So anything which is supported by Hadoop, you can use it as a target. I'm not sure, but GCP and ABFS should be already supported as well. But we are testing on S3.
Have we tested Azure at all? Like I think we test S3.
We haven't run any test on anything other than S3 at this point.
Okay, sounds good. Thank you.
Cool. Thank you so much.
Cool. Thank you, guys.
Thank you.
Next person is Raj, the DynamoDB on Phoenix.
That's cool.
Okay, so we are going to talk about improving HBase and bringing it to more like a sort of unified database store. So whether you have human beings or AI that is going to decide what kind of data store you want to use, there are certain functional and non-functional criteria that you go through, right? For example, is it like highly available data store you need, or is it like strongly consistent data store you need? Do I need asset properties? Do I need document store, or the key value store, simple key value, or do I need graph database, right? So when you look at HBase, we all know that it's strongly consistent database, right? And it's like wide column family oriented database. But there are ways that we can provide various interface to make it like far more than what it supports as of today. So if you look at DynamoDB, it's like it's also a key value data store. MongoDB is also a key value data store, right? Similar to HBase, but they support like different kinds of use cases. Like one supports document data store. So when you have records which support complex set and map within map, right, kind of document structures. So then someone wants to go use DynamoDB or MongoDB. But when you have like simple column-oriented storage, then one uses HBase. So today we are going to discuss about how is it that we can incorporate more use cases in HBase in a way that you don't have to use like all different kinds of storage for your use cases, but various use cases can be supported by just one unified storage system, and that could be HBase and Phoenix. And I'm also going to cover why Phoenix and not just HBase. So let me start off with what we use in big data at Salesforce. What is our tech stack? Very quick overview of HBase, Phoenix, and DynamoDB, and why is it that someone should use Phoenix HBase over DynamoDB, right? And how is it that we reverse engineer DynamoDB APIs for HBase in a way that someone can use AWS DynamoDB SDK to connect to HBase instead of DynamoDB without even making any code change, right? And so, yeah, we are going to go through some technical details and what kind of upcoming HBase and Phoenix releases will unlock this new open source feature. Okay, so the big data at Salesforce, we ingest like billions of metric data point every day. We read like historical as well as real-time metrics with very low latency. It's interesting, you know, there were like, I think around 4 to 5 years back when I was looking at HBase, and there was a single cluster of this metric data store, and it was serving more than 85 million request read and writes per second. So that's like pretty impressive, some of the use that we have. It's backing store for like many of our major platform features that generate the high data volume at scale. So we do have like, you know, single row point lookup, low latency kind of use cases, but we also have highly analytical, high throughput use cases, which process like trillions of log lines every single day. And we also have the data migration frameworks for very large tenants. So the tables are multi-tenant, and the part of the table which stores the tenant data that needs to be migrated from one infrastructure to another, like from AWS to like private data center, right? For the security, we use Kerberos and service mesh, and we use HBase for like the system of record compliance. So this is what the high-level tech stack looks like. We use all of these technologies, and so yeah, a bunch of these are like open source. Yeah. So a very quick overview of HBase and Phoenix. So HBase is horizontally scalable real-time key value data store with wide columns, as we all know. It is designed for like very high volume read and random read-write access. Phoenix is a bit different. So it provides a SQL access on top of HBase, but it also works as HBase coprocessor. So it's horizontally scalable relational database, and it uses HBase as its backing store. Now there are several features that, you know, Phoenix complements HBase with. Like HBase doesn't have secondary indexes, global and local secondary indexes. It doesn't have multi-tenancy concept by default right out of the box. There is no change data capture, right? So Phoenix complements HBase with all these features, and there are many more than that. There is also transaction. So when we use Phoenix with HBase, we provide like all these you know, features that other data stores provide. Yeah, we have seen, like as I mentioned, we have like millions of requests per second per cluster, and so HBase is like strictly OLTP, and yeah, you can use MapReduce jobs to make it like a bit of an OLAP, but Phoenix is like you can just write whatever SQL queries that you want to write, right? So you can access large volume of data with just one SQL query, and behind the scene, it will just parallelize the task, something like Trino, but far more faster than Trino. So Phoenix is like a combination of OLTP and OLAP database. Very quick overview of DynamoDB. So as we know, DynamoDB is one of the most famous database out there in the world of NoSQL. It is like fully managed NoSQL database provided by AWS. It is key value store with document data model. So this is where HBase and DynamoDB are different. HBase is key value store with wide column families, and DynamoDB is key value with document data model. As per the Amazon, DynamoDB is the planet scale database because they have like over 1 million customers as of 2024. That this comes from one of their blog posts. And what they support, the most important thing which they support is that predictable performance at any scale. So you can predict, depending on your data volume and the throughput that you are expecting from the system, you can predict the range of the latencies, and your request will never go beyond that, right? And in order to do that, of course, it is like highly available database, so it is not like strongly consistent. So these non-functional aspects of the systems is not something that we can match as of this moment. But there are like very high level features that DynamoDB provides, which now we also support, and kind of trying to make HBase on par with DynamoDB so that anyone can use this. So it's like the global and local secondary indexes. There are various data types like scalar, the nested documents, nested list, and the scalar sets. There are highly scalable change data capture. There is also a little bit like weird concept of this TTL. So in HBase, when your row expires, the TTL expires, then you can't read it, right? But DynamoDB allows you to keep reading the row until the major compaction happens, and that's probably it's by design to keep things simpler. There are various complex conditional and update expressions so that's something that that DynamoDB provides. So it's like something like SQL, right? So in the SQL, whoever is familiar with SQL, they know what kind of queries work with Oracle, MySQL, Postgres, and they are familiar, and that's the sort of a language, right? But the usage of DynamoDB with over 1 million customers as of 2024, right? That itself suggests that all these expressions that DynamoDB supports has also become a language for something like document data store. The another one is MongoDB. They also have their own language of accessing the database, and that's why they have also set up a standard. They support the backup restore with global tables with multi-region replication and cross-table transaction as well. Okay, so why is it that someone should use Phoenix HBase over DynamoDB, right? So this is something that if you use DynamoDB, then obviously it's only in AWS. It's a black box. We don't know what's going on behind the scene, right? But when you use HBase and Phoenix, it's an open source technology. You can deploy it on AWS or any other cloud providers. It provides the consistent performance across all substrates. All you need to do is make sure your configurations are right and unique across all substrates. There is no vendor lock-in, there is no code change needed. And of course, it will be far less expensive than DynamoDB once your data volume grows beyond certain limit, right? It provides, yes, we can get like flexible performance based on the use cases. Like if you have high throughput overlapping use case, then you want to make sure your block sizes are larger and you are accessing large amount of data in one shot. We can use multi-tiered storage like SSD, HDD, and S3, depending on, some tables can be hosted on S3, some still on SSD. There is no hard limit on the number of tables. HBase accepts row size larger than DynamoDB, so that's also one more use case for anyone using DynamoDB to use Phoenix HBase. And of course, we can provide the variety of compression algorithms in HBase, not something that DynamoDB would support out of the box. They would just charge us for whatever data we write. And then there is tunable read consistency. We have the read replica feature, right? So, and then of course there's optional HA mode with replication, something we can cover later. So how does it look like at very high level, right? So someone is using DynamoDB SDK. It's written in Java or Python or Go, and it automatically connects to DynamoDB, right? So as long as you use AWS, you have DynamoDB REST servers which are like accessible, and this is how you just read and write your data. But the architecture that we are coming up with is we have Zookeeper, HBase, and distributed file system, right? But then we deploy Phoenix REST service. So like when you keep like load balancer on top of the REST servers, so the DynamoDB, all you need to do is point your AWS DynamoDB SDK written in any language to just this REST service, and behind the scene, it will just access the data from HBase. Your application wouldn't even know the difference between using DynamoDB or HBase Phoenix. So how did we reverse engineer everything, right? So when you want to provide the same experience as DynamoDB, it's not just the APIs that you need to provide. You need to fundamentally change your how you store the data, how you structurally parse your language, which is used to to filter some data or write certain condition expressions or update expressions, right? So what I'm trying to say is that in order for us to support a new data store, we need to support their fundamentals in the first place. So we evolved Phoenix into DocumentDB, and the reason why we wanted to come up with this binary JSON as complex document structure in HBase first, but since HBase doesn't support the index concept or like global secondary indexes, local secondary indexes, change data capture out of the box, right? That is something that Phoenix supports. So we directly introduced the BSON in Phoenix. So it supports now that's not sufficient. We also support the set of the scalar data types like string, number, binary, because there is no concept of set in the document storage like JSON or BSON. So that's an additional work. Now we also looked into MongoDB and DynamoDB, and since we wanted to make this like unified data store, right? So in future, someone is using MongoDB, even they should be able to use HBase without making significant code changes. So we have introduced like condition expression and update expression that of both styles that match like DynamoDB and MongoDB. So we support like all the atomic updates, range scan, full table scan with some filters, or you provide the partial or full document updates, right? And then there is of course the global secondary indexes on the top level as well as nested document attributes. We have the primary and secondary key indexing on binary data types. That's an additional thing we supported. And we have the atomic and conditional updates with returning old and new image of the row. So it's like you make the conditional update to a row, and then you get the answer as in like, is my row newly updated, or is it still on the old version, right? So you get the version back. Those are like the kind of APIs that DynamoDB supports. So, and then change data capture streaming support. So after supporting all these features and a bit more, then we were able to set the fundamentals for evolving Phoenix into a document store. And only after that, we can build the REST service on top of Phoenix, which can convert the DynamoDB request into Phoenix SQL, which then uses HBase client to execute the queries on HBase servers. So these are like the additional features that we built. Antler grammar for BSON condition expressions, and then on duplicate key, which is for the atomic updates. We also introduced strict versus relaxed TTL because that's what DynamoDB follows. And then there are several functions that we supported with this. There is the eventually consistent global secondary indexes that we are working on in Phoenix. So this is kind of unique because there is no database in the world that provides you both strongly consistent and eventually consistent global secondary indexes. So Phoenix would likely be the first one in that category. Okay, so the document data model is very simple. You just need, in your table, so this is like HBase table, you have, let's say, column 1, column 2 is your primary key. The combination of them forms the row key. And then the third column is like of the type JSON, in this case, like binary JSON, so BSON. And then you can like, either you can upsert the data. Phoenix uses the word keyword upsert because like the put mutation is same, right? Either it will overwrite the data or it will create a new row. So there is no like insert versus update. So when you upsert the row, you can provide the document upfront, or you can do the partial document update by introducing some functions like condition and update expressions, similar to what DynamoDB does. And you can just pick any field of this document and create the index on it. So this is what the change data capture looks like. And by the way, this is something that can also be used for the incremental backup purpose if we want to use it. So what happens is the request goes, let's say the write request goes to HBase client, it goes to several regions of the data table, and then we build a CDC index. So it's like very lightweight, uncovered index. All it does is it keeps track of the partition ID, which is like the region name, right? So in this case, we have region 1, region 2, region 3. And then we have the Phoenix row timestamp, which is nothing but the put mutations timestamp. So whenever you write the data, you note the timestamp, and that's the same timestamp used here in the index. And then, of course, we have the data table primary key embedded so that you can convert from this uncovered lightweight index back to the HBase data table. And all it does is when you want to find out what change happened at any given moment, right? All you need to give is the region that you are interested in of the HBase, then what are the row timestamp you are interested in, and what are the row keys. So based on the data table row key, you can scan the original data table, get all the cell versions, and you can find out the pre-image and post-image of what was the before change and what is the after change. So that's the change data capture streaming that we've introduced. And as you can see, like there are individual consumers that can consume the region-specific information because if one there is no like unique CDC consumer that can consume everything because that would be too much of a records to consume. Okay, so the Phoenix DynamoDB adapters, as we open sourced this project very recently, so there is no like official release yet because we are still waiting for HBase and Phoenix releases. So the idea is simple. You have DynamoDB REST APIs. All you need to do is convert it into Phoenix SQL, which goes to HBase client, and from HBase client it goes to HBase server, where we have Phoenix coprocessor. So these are like very high level just details. Like DynamoDB API request looks something like this. It has table name, key schema, then it has attribute definitions, global, local, secondary indexes, and then stream specification. And we converted everything into Phoenix. In Phoenix, from HBase viewpoint, every index is a new table, by the way. So every global, whenever someone says, I want to create the global secondary index, that's going to be a new table in HBase. So we create like primary table and then followed by whatever number of indexes that we need to create, and then we create the change stream. This is what the other DDL APIs look like. So you have delete table, describe table, list tables, update table. These are like just the DDL ones. And then we have like, single row read, where you provide the full primary key so that we can convert it to HBase row key. And then we have the batch get item, which is like multi-row point lookup plan. Then we have the ren scan, which is like, so when you have, so in HBase, you have the one row key, right? But Phoenix support multiple composite primary key. So it's like you can specify 3 columns together as your row key, right? But now someone can say, well, select star from table where the first column value is this. So it becomes like ren scan in HBase terms. HBase has to scan with the scan start row key as whatever is the first primary key's value, right? So it will do like sort of a ren scan in your scan contains start row key and the end row key. So that's something that we support. That's something that DynamoDB supports. So we have the same support here. And then there is full table scan. So it just keeps going on. But there is one special concept in DynamoDB, which is like the segment scan. So in terms of HBase, you can consider it like you have a very large table and you have multiple regions. So let's say you have 200,000 regions, right? And customer, the client application can say, well, I want to parallelize the table scan. So give me 10 segments. So we can divide 10 segments such that each segment, the 200,000 regions. So every segment can only read 20,000 regions, right? So it just keeps parallelizing among based on the number of regions that you have. And in parallel, you can do the segment scan. So that's a very interesting concept in DynamoDB, and we implemented here in Phoenix. And yeah, then there is, single row put item in a way that, it can return the values, like, whether your conditional or atomic update took place or not. So depending on that, it will return the value. In the update item is clear, so it updates the existing value. But in case of HBase, there is no such thing as insert versus update, right? So we have taken like special care of, how is it that we can formulate the statement that it will make sure that, there exists a row, you read it, and then, you update the value if it is atomic update. But if it is just like, without any condition, then you just directly go and submit the put mutation and it will take care of updating the row. And then there is delete item, which is like just a single row delete. And you have the batch write item, which is like you batch the multiple updates and deletes together in the same request. Okay, so the upcoming HBase and Phoenix releases that we are waiting for is 2.5.12 and 2.6.5 because it has some fixes. The Phoenix 5.3.1, and then we can do the first release of Phoenix adapters. So yeah, if you have a at your organization, someone is using DynamoDB and worried about the cost. As the data grows, the cost will grow. So you can use this new way of deploying HBase with Phoenix and have the Phoenix REST servers running on the top. So they can take care of converting your DynamoDB request into HBase eventually. And your application wouldn't even know the difference between whether it's talking to DynamoDB or HBase Phoenix. So yeah, here are some references. And any question?
Do you run it in production?
Yes, we are starting to run it very soon. So yeah, it's like not in AWS at this moment, but the new the non-AWS environments is where we will run it first, because so that eventually we can also run it in AWS. And yeah, but right now the use cases are like we have like the sort of a metric kind of use cases which will use this, and there are some internal tools which are using DynamoDB, so they will use this. But in terms of verification of how solid this tool is, there is a service which we have in Salesforce, which is like sort of an database store in it itself, which uses DynamoDB behind the scene. And so it has like, I mean, when we run the test, it takes like 2 days just to complete their test. So we ran this framework by running that service and kept the DynamoDB REST servers in the backend, and we were able to verify that everything works fine. So that gives us the confidence that we are able to convert almost everything from DynamoDB to Phoenix.
So basically, they're delivering two major features with this Phoenix release. One is that Phoenix is now able to handle documents, DocumentDB,
right,
and the DynamoDB interface.
Right. Yeah,
that's incredible.
Follow-up question about those like verifications, but DynamoDB is known for their very like fast like performance. Right. But now I have a question there about you allow more than 400 KB like per row. Then when you create DynamoDB, I don't think they give you a API to say, hey, I want various size of the row, and then you don't specify. That means the row right now is up to whatever you set 1 to 10 between them. Do you see any like latency issues? Because like people can write the code differently, just like some tiny one. At the end, you have a like 5 to 10 megabyte one. The jumping in between the scan and like. What do you see the latency when you verify your stuff?
So it's one of the I mean that's just one of the points that I wanted to mention, that HBase can support so like why use. So this is more like this is what HBase supports.
Yes.
But it doesn't mean that the use cases will use them, because the reason why DynamoDB caps at 400 KB is because they want to worry about the performance, right? It's like
read performance and write performance.
Read and write performance. So that's the same thing that happens here. It's like we cannot defy the rules of physics, right? So it's like if someone uses the 10 MB, then of course the latency is going to be way higher than.
Is it fixed? I mean, I'm asking, when you create a table, do you want it always like fixed?
Not now, but we have. So when someone puts the data in it, right, at that time we have verification that the item size should not be more than 400 KB. But yeah, you have a point. I mean, when we create the table, we can set it right up front. It's just the HBase server key value, I guess. That's the config. So, yeah.
Another question I have is the multi-tier storage. I'm not familiar, but I look it up. Like, how do you confirm the multi-tier storage? Because is that the HDFS? Whatever.
It's the HDFS. Yeah. So there are various mechanisms. So one of the things that we are exploring is the allocation, and it's so it's a common file system, and then behind the scene you can have HDFS,
They help to like do it automatically. You don't have to think about that.
Exactly. Yeah. So it's like based on your path in the file system, it figures out whether the data is in S3 or in SDFS. So the reason why I said multi-tiered is because the SDFS on and on itself has like multiple tiered. Like you can set up one table backed by S3 and another one table backed by SSD, another table on STT, right? But then you have one more layer on top of it, which is Alluxio, so that can take care of S3 based storage. So you can host some tables directly on S3 and
because I don't remember like DynamoDB has that.
Yeah, DynamoDB is like strictly everything.
And
is
I was thinking
SSD.
you introduce a new feature on top of it.
So no, so my point.
Because if you have to ask people ahead of time, I feel like we always say that. We keep saying that. Like even HBase has been thinking of we have to have multi-tier storage, and then you created the HBase table based on the tier. But like looks like really like old school. Like you have to think ahead of something. Then
It's mostly from the perspective that when someone uses when the use case is using DynamoDB, right, they would expect similar performance from HBase. So my point is when you have a large HBase cluster, there are tables which are not so latency sensitive. So they continue to be on STD, but when you create a table, which is like the DynamoDB customers expect, right? So then you can host them on SSD and you can get the superior performance for them. So from that viewpoint, what I was trying to say is that in a single HBase cluster, you have option to host different tables.
I misunderstood. You already have that. So
you mean the production?
Yes.
At some extent, but not entirely. We are still exploring the S3 approaches.
I have another one. So you guys have the containerized HBase. Is this one on containerized HBase?
You mean the Docker setup? And,
yes. No, you guys.
Kubernetes. Yeah.
So everything is on that one, including Phoenix.
Sure. Yes. Wow. Because, but those are the. I mean, there is a blog post that I can share from.
I know
from our side. So it's like we have what we call the stateful sets, right? So in the Kubernetes stateful sets will take care of SDF because SDFS is stateful,
right?
Zookeeper is stateful, so they need the storage attached. So in the Kubernetes world, when you kill a pod, the new pod comes up. It might have different IP address, but still it needs to connect to the older data, right? So the way it happens, Kubernetes provides a stateful set, so that takes care of it. So yeah.
Okay, thank you.
Question on the multi-tiering, right? So like multi-tiering allows you to use a single HBase cluster backed by different storage, right? Like what made you have that decision support on HBase instead of just like separate the HBase cluster? I have an SSD HBase cluster, I have an HDD HBase cluster, I have an S3 HBase cluster, right?
Yeah, it's mostly the cost. So when you share the same SDFS cluster, your cost will be limited to it, right? Because if you now use that you have the two different SDFS and you need to take care of the replication factor for both of them, and so yes, you're right that by creating the smaller HBase clusters you can get more performance, but then it increases the cost because HBase is not the only service that comes on a cluster. You have Zookeeper, you have HMaster.
Right, but you can have multiple HBase cluster backed by the same HDFS.
Well, in that case, what happens is when your one AZ goes down, then you have outage which spreads across multiple tables, right? And it becomes unpredictable to make sure that you remain highly available even when the AZ failure happens. But by combining there are separate ways. I mean, we can talk about the AZ failure resiliency, but that's the main point. Like having the cost and not unpredictable AZ outages that can screw up multiple clusters. Because sharing this single SDFS by multiple HBase clusters would only give you advantage at the compute layer, region server, but there is no other advantage.
Hey, Viraj, can I also make a comment here?
Sure.
Yeah, it's not only about AZ resiliency or whatever. We have policy-based restrictions on. We have a cellular architecture as far as how customers are allocated to clusters, and we have policies specifying limitations on blast radius and things like this. So I mean, it's more complex than just AZ failure, and that blast radius considerations are specifically why sharing an HDFS cluster among multiple HBase clusters is not viable.
There was another question, Silo. Your question, do you want to ask about it?
I asked about you mentioned the eventually consistent global secondary indexes, which is a new feature, this development. So what's a use case for it?
So the use case is same as DynamoDB. So what DynamoDB provides is like up to 20 eventually consistent global secondary indexes. And what that means is regardless of whether you have an index or not, the latency, the performance, the latency and throughput on the data table writes should not deteriorate. So but today if someone uses Phoenix with the synchronous index mode, what that means is write request goes to a HBase table, and the Phoenix coprocessor will take care of writing to multiple indexes simultaneously. So you have the network cost and you have the cost of.
You have to wait for it to be finished.
Yeah. So that's just to match the performance of DynamoDB.
So basically, it's the asynchronous version. So
Yeah.
you don't have to wait. Oh, got it. Right. Cool.
And I wish I can share more details, but it is also based on the change data capture that we are using. So it's in progress, but it's coming in open source very soon.
I have a question on the Zoom here. Thanks for sharing. I saw you adopted the same pattern for the key constructions from DynamoDB as well. I guess Dynamo has like partition key and sort key. I think I remember seeing on the slides for HK and SK. Could you kind of explain more on what those stands for and like kind of the reasoning behind those?
Yeah, it's just an example of that, what your partition and sort key will look like. So it's like hash key and the sort key, more like.
Oh, hash key. Okay.
Yeah. So it's just a column value. Like HK, which is the hash key, the partition key is going to be the first primary key column, and the sort key, which is the range key, is going to be the second part of your composite primary key columns. That's it.
Okay.
That's a good question.
Yeah, thanks.
There is another question in the chat room from Zuber is what happens as the DynamoDB API changes or evolves over the versions? Basically, it's SDK upgrade, and then like more feature they support, or like let's say deprecating some API or something. What will you guys do?
Okay, so as far as the SDKs are concerned, they would continue to work with whatever DynamoDB has. So DynamoDB hasn't changed their API since 2012. So so the reason is and that's primarily the reason, by the way. When we started this project, we wanted to support the SDK level support. So like on the Java level itself, without writing any REST servers, whenever someone just creates a DynamoDB client, they can provide the Zookeeper quorum, for example, right? And behind the scene, Phoenix JDBC can take care of connecting to the HBase cluster. And so there is no like REST server in between. But then we realized that, there are some parameters which are deprecated. The APIs keep getting changed. There is a concept of mapped table in DynamoDB, right? So the SDK. So and then there are more SDKs like Go, Python, and all of this, right? So how do we make sure that everyone using any of the AWS SDK should be able to connect without breaking any compatibility, right? And that's when we decided to move on to use the REST service approach. So yeah, since DynamoDB hasn't changed anything in the REST service, we don't expect like anything should not work. It's only about like what new logic or new APIs are getting introduced in the DynamoDB SDK. So the SDK will make sure that, whether you use the map table concept, whether you use asynchronous request, native-based async IO, eventually the HTTP REST API that it needs to hit to DynamoDB, right? The real DynamoDB, that follows the exact same contract that DynamoDB has published in the in their API contracts. So as long as we follow the exact same contracts in Phoenix, everything is going to work out of the box. Yeah, there are some applications which I'm aware of. They use like the asynchronous non-blocking IO to access the read and write APIs. So they like DynamoDB SDK. Apparently, the AWS V2 has the support of this native-based IO, and they return the completable future. So you write something and you return the completable future, very similar to what HBase has, right? In the admin and table APIs. So that's what they support. But for that, we did not have to make any changes because as long as the HTTP level contracts are same, everything is just going to work. Any more questions?
Maybe one last question is about their security model using IAM.
Yeah,
And
that's a good
now
question. Yeah.
you didn't mention anything about that.
Yeah, that's an interesting one, right?
Yeah.
So because we can, since we cannot access the AWS internal IAM records, like there is no way we can support that. But so what we have is we have provided a framework for someone to retrieve the access ID and the private key from the headers, and then they can implement their own way of, like, let's say, for example, you're using a SIG vault internally, right?
Yeah.
So all you need to do is make sure that the access ID contains some value for a customer that, that is in your vault with some access. So whenever, like in AWS, everything is automated. Like you can just generate the new key and private key and access key, right?
Yeah.
But here it will have to go through your private company specific vault or security solution that you have. It has to go there and then customer can start using it. So yeah, so we have the framework, but yeah, that's all we have.
Then
Does it work with if the cluster is Kubernetes?
Yeah, so as long as if it is Kubernetes, then it should, yeah, it will work, yes. But that's more about, between Phoenix REST servers and HBase. So that connection will be Kubernetes.
Okay.
But there is no security between DynamoDB SDK and REST endpoint, right? So I guess your question is more about.
right, because I'm thinking about they would judge about the end-to-end, like whatever security encryption and stuff. Then they will don't know what to do. But
Yeah. I mean, currently it's like as long as your client is in a cluster which has like sort of service mesh, and the whole HBase cluster, including Phoenix REST service and load balancer, is in a different cluster, and they both follow they can make sure of the authentication using the service mesh. It should be fine. But since we are open sourcing the framework, so all it will do is like you just need to provide a custom implementation and provide the configuration with it. So it will take care of retrieving the access key and then making sure it is available in your secret vault.
thank you.
Oh, thank you.
You also like localizing the data. So in DynamoDB, when you create a secondary index, you have the partition and the sort. But ultimately, the data model itself is also making sure that the data, on the key that you have sorted index, it also makes sure that all the data is lying in the disk like locally and in the same. Are you also like doing the same people?
So I think
N plus one queries.
probably you're talking about the local secondary indexes or even in general?
Global secondary.
Global secondary.
Global.
I see. So for the global secondary indexes, in terms of HBase, it's going to be a completely different table. So you have like when someone creates, let's say you have a data table and then you create 2 indexes, which means in HBase you have 3 tables, and it will just take care of the data locality will belong to wherever the HDFS blocks go, right? So that's all. But as far as the DynamoDB is concerned, I think they follow somewhat similar in the sense that they also consider like index as a separate table. Because if you look at the APIs of like scanning the index, then they specify instead of table name they have like the index name, and so the way they have designed it, it makes you the feel of index being completely separate table. But in Phoenix we have this global secondary index for like many years, and it follows the same concept.
There's a question in the chat from Zuber. What happens as DynamoDB API changes or evolves?
API.
You answered that.
I think that's answered, yeah.
Yeah. Oh, yeah.
Have you already covered it?
Yeah. Yeah. Question on the REST server, right? So what's your guideline in scaling out the REST server so that like your DynamoDB client has the same like performance as like a native Phoenix client accessing region servers direct?
I see. So let's assume that if you are using the Kubernetes stateless model for the REST services, because the REST services are like completely stateless. So all you need to do is like just define the auto scaling algorithm based on the CPU percentage uses and memory. So right now we are using it at like 75%. So as well, the moment when one REST server becomes hot enough to consume 75% of the CPU usage, then we spawn more instances. So it's like completely stateless. So it's
right. So you have a correlation between API client performance and CPU.
The only problem is when the new server comes up, it will have to connect to HBase cluster, and then it will for a moment we see the spike. So yeah, you have a right point. Like whenever we do the performance evaluations and the new server comes up, then we have a temporary high spike. But that's the problem that we need to solve anyways for HBase, in the sense that how is it that the HBase thick client can scan a completely new table without having anything in its memory, right? So let's say if you're scanning a table and you keep 2 MB worth of data in your cache, and so the subsequent scanner.next will keep serving from your local cache. But here, since everything is stateless, everything has to be queried again, and so yeah, there will be a spike in the database when a new server comes up. Okay. But if the other thing is, if we know the provision throughput capacity that customers are expecting, then we can spawn those many servers beforehand, so that they can take care of uniform, predictable latency. But yeah, otherwise it's a bit hard to manage when you have auto scaling.
Right, because like you can apply that same like scaling logic with like the native HBase REST gateway.
Right, exactly. Yes, right. Yeah.
Thank you.
Cool. Any more questions?
Good. Thank you, Raj. We have 2 more, although the pizza is here. How about maybe after
lunch break?
So you guys also, from the HubSpot side, you guys also reserve until 4 o'clock, right?
Yeah.
Let's have a 5 minutes, like grab the pizza, and then we can continue about that.
Yeah.
Because I don't know whether we have enough time.
That makes sense.
All right.
5 minutes.
5 minutes break.
So
I'm back at 12:00. Sorry, like you guys are 3:06. Thank you.
Pause the recording.
Yeah, I'm even going to do that.
Cool.
I'm gonna stop.
The rest.
Okay.
HBase data caching, bucket cache, and beyond. Vladimir will do. So the agenda today is we tackle the background data caching in HBase, and we discuss bucket cache challenges. Then we discuss the new pluggable cache architecture. Actually, was pretty new submission last week to the community. Then we consider what potential bucket cache alternatives exist, and the last small section is a future roadmap. Data caching is very important for any database. This is why actually the first version of HBase pre-0.96 already has cache implementation, which was available below cache with a very simplistic on heap, limited by heap size and with a high garbage collection for HF scale. So there were a lot of complaints actually related to this cache implementation at that time. So around 0.96 version, it's probably somewhere. I forgot, frankly speaking, what was the timeline which the bucket cache was introduced. It's probably sometimes around 2012, 2014. But it's probably already not 0.96, it's more close to 1.0. And nevertheless, it's a long time ago. So this bucket cache was introduced by Intel for heap and file back caching work. And it was designed to overcome heap limitations. There is another version actually that it's basically was created in collaboration with between Intel and there was a startup called Fusion.io, which was the first actually inventor of the enterprise SSD on the market at that time. So the key idea was to move data blocks of heap and to external storage, such as SSD and memory map file, and keep only lightweight metadata on heap. Immediately, everybody noticed the performance improvements. So first of all, it was possible to create much larger cache sizes because moving off heap actually allows you to allocate all the available memory on the server, not only available for the region server. Definitely because you move all data off heap, so you reduce garbage collection pauses because you don't have to a lot of data on Java heap. It improved scan and render performance, and later definitely this bucket cache became the building block for the object store back deployments. So without caching, these object store deployments are very pathetic in terms of performance. Architecture, very simple. Level 1, still on heap, LRU block cache, mostly used to keep the metadata block, like blooms, indexes. And level 2 is a bucket cache, either off heap or on disk. The impact was very profound, so it became default production configuration and was critical for large clusters and cloud deployments. Trade-offs and limitations. First of all, of course, metadata overhead. Significant on-heap metadata footprint. From the one of the most recent the RFC documents I read from our team by Wellington, I found this reference that only 1.6 terabyte of cache with 64 kilobyte blocks, almost 9 gigabyte of heap memory consumed for the metadata, which actually pretty large. So this large overhead for metadata reduces effective cache capacity. And definitely these metadata structures are not optimized for extreme density. What next? Another potential problem with this bucket cache implementation inside HBase is architectural coupling. Because this implementation basically combines storage engine, eviction policy, admission logic, L1, L2 configuration assumptions, and this makes evolution difficult, hard to introduce new policies, and for example, hard to plug alternative engines. Because to create alternative engines, you just need to implement a lot of stuff, and basically it's really hard to make it pluggable with the current implementation and design. From bucket cache to new architecture, what we learned from bucket cache? Yes, off-heap caching is essential for scale. Tiered design L1, L2 works well in practice, and definitely caches improve read performance. But key limitations remains. Already we mentioned it. Metadata overhead, tight coupling, and hard to introduce new cache engines. So design directions is decouple and generalize. Move from monolithic cache implementation to layered pluggable architecture. Separate storage, which is engine itself, topology, L1, L2 orchestration, policy, admission, placement, promotion. Introduce explicit admission control, flexible representation strategies, and support for alternative edges. For example, carrot cache. Representation strategy is basically the system your implementation describes. How do you want to keep the data in the cache? Should it be compressed, encrypted, encoded, serialized, etc., etc., etc.? It's a kind of new feature in this design. Proposed pluggable cache architecture. It's a new ticket in HBase 30008. It's umbrella. It has multiple sub-tickets already. Was created last week. This particular ticket contains the reference to the pluggable cache architecture design document. So you can find the reference there. So this architecture proposed decomposition. So the current block cache responsibilities are split into 4 layers. HBase facing facade, which is a cache access service. So basically, all HBase components will be working with this cache access service. That's the only available entry point to the caching system for them. So basically, this is what AH file reader implementation and the write path code call. Second one, topology orchestration. Coordinates levels and moving data between levels, handles promotion and demotion. So demotion is when the data is evicted from, for example, level 1, and it can be promoted to the level 2, but it depends again on the cache topology implementation. Placement admission policies. So basically, it decides where blocks go and how they are represented or where they are admitted. So basically, it's admission, definition, representation decision, and etc., etc. Basically, this is first 1 to 3 layers in the new proposed architecture. They are cache implementation agnostic. They actually can be developed and will be developed absolutely separately and can be used with any cache engine. And any cache engine will need only to implement storage implementation, which is a block cache engine. So this is basically actual cache engine, LRU, bucket, carrot, etc. So this architecture and this decomposition will make this pluggable thing much more simpler. And for the developers of the cache engine, so they will need to implement only one interface contract, which is a block cache engine. Let's talk about each layer separately. Cache access service. This adapter used by HBase read path and write path. So what does it do? It hides the whole topology details from reader and writers, translate existing config, cache config, and request into cache request context. Centralize get, put, and validate semantics. So basically, it's kind of the current block cache with probably some slightly bit different methods of implementation. So some methods in the block cache, they seems very bucket cache specific, so they will be removed in this particular cache access service. So this is basically cache access service provides the HBase related API rather than exposing engine topology details everywhere. So like for the HBase itself or for the read and write path, it is a replacement for the block cache basically interface. Cache placement policy, many tasks. Should the block be admitted, for example? And if admitted, or which tier should store it? Should hidden L2 be promoted to L1, and when? Should invalidation demotion remove or move state across tiers? Should blocks distort packet or unpacket? Should the write path population be treated differently from the read miss population? So this is basically, do we need to cache something on write, or what type of objects, or what type of blocks, data blocks we store on write? Cache topology. It's a coordination level between different cache engines. So it routes reads to L1 or L2, apply promotion, demotion, merge statistic when needed, expose a single block cache compatible facade to the rest of HBase, coordinate and validation across participating teams. Examples, single level topology, tiered exclusive topology, tiered inclusive topology. Exclusive topology means that, for example, in case of two tiers, L1 and L2, all the data will be kept in tier 2, and some data will be kept, hot data will be kept in tier 1. In tier inclusive topology, some data, hot data, will be kept in tier 1, and the rest data will be kept in tier, vice versa. So inclusive tier 2 basically keeps all the data. In exclusive topology, tier 2 keeps only colder, warmer data, and the hot data will be kept in tier L1. So this is, again, so all behavior will be defined in this implementation of this particular interface contracts. And as I said already, they are cache implementation or engine implementation agnostic, so they can be used with any different type of cache engines. Block cache engine. This is basically the cache itself. So this responsibility, of course, store and retrieve blocks, maintain implementation, local retracement, admission, expiration logic, expose occupancy and statistics, support file-based validation, support region-based validation. This is going to be a new feature. I don't remember actually if the current bucket cache supports region-based validation. But if it supports, it's basically this will support as well. File-based invalidation when we rewrite files during compactions. So, and all these cache data blocks must be invalidated immediately when these files get deleted. This is definitely will be supported. And the region-based invalidation when we move region between region servers. So these obsolete data from the regions which was moved will be invalidated immediately as well. So it's non-responsibility, of course, it doesn't do anything with the promotion, demotion, placements, translation, topology, and cross-tier routing. This is going to be the phase approach, and phase one, it's an internal API foundation. So introduction, the new internal contracts without changes default behavior completely, basically. So it's this phase one won't affect at all the existing implementation. Phase 2, move combined block into explicit topology layer. This is probably one of the major refactoring which is going to be done. This is why it has a dedicated phase itself. But even after phase 2, everything still remains the same. So the current implementation works as usual. Nothing can be changed. And only after phase 3, when the bucket cache will be re-implemented at the pure engine, so we will basically go to the configurable deployment where the customers will be able to try the new implementation using some configuration switch or just use the older one. Phase 4 will introduce the new implementation, which is carrot cache. We will talk about the carrot cache later in this presentation. This is a new caching library which has some very interesting features. Bucket cache. This is a carrot cache. This is a high-level design. First of all, carrot cache, it's open source. It's Apache 2. It's very new. It's definitely, it still doesn't have any real customer yet, but it definitely has some interesting parties which try to use it. Several years in development by Carrot Data, which is a company founded by me. Small team, 3 developers. The original actually idea was to make this definitely pure Java and make it absolutely configurable engine. So as you see, this is grayish rectangles on the diagram. They are all pluggable. So you can actually configure and replace and use any of them. There is a different implementation for this. Different controllers, promotion controllers, data writers, data readers, index format, eviction policies, everything basically. So you can actually you can write your own, and you get your own implementation. So like, what are the major features? So highly scalable, pure Java with unsafe, of course. It implementation doesn't use Java heap practically at all. So it's very low. So I was able to run terabyte size caches with in a Java with a Java heap 60 megabyte of size. Multiple modes of operation, RAM only, SSD only, hybrid RAM SSD, and even tandem mode when you can allocate the part of memory for the data and another part for the compressed data. So basically, you can actually use you can store more data in the same amount of memory, like hot data in the first layer and level, and the compressed data in the second level. Scalability currently is limited by 256 terabytes. Definitely, we haven't tried yet. It's pretty huge, but we tried our memory index implementation on the scalability and concurrency. And memory index is memory index, first of all, support incremental rehashing, absolutely concurrent, and can store billions or tens of billions objects. So it's very scalable. Maximum size of the memory index we tried in the benchmarks was around 5 billion of objects. For 5 billion of objects in the cache. Yes, it's as differently. All writes operations are sequential. This is a big difference with a bucket cache, where all writes are random. Oh, there is a yes. From the SSD longevity point of view, random writes definitely bad. But frankly speaking, few customers actually care about this. But this IO API, which Carrot Cache requires, random writes and random reads and sequential writes, is fully covered, for example, by Hadoop file system. This make it possible to adapt Carrot Cache to use Hadoop file system as underlying storage, and you automatically get the basically distributed implementation and replicated and highly available. Warm restart support, very fast actually, operates at IO maximum speeds, measured in gigabytes, multiple gigabytes per second. So you can save cache, you can load cache, so it's very fast. And one of the major features, advanced compression, supports the standard with the dictionary compression. Dictionaries created on the fly, so it's a continuous adaptation. So there are some metrics which engine tracks, and when the compression ratio efficiency drops below thresholds, the new training process starts, and the existing dictionary later replaced with the new one. This was implemented in the product Memcarrot, which is the open source caching server, Memcache compatible, built on top of Carrot Cache. So this is a feature we actually tested thoroughly in the Memcarrot. To find this information, I just Google Carrot Cache. You will get the first reference, the page, which is point to the GitHub repository. I just missed one very important feature, a very low memory overhead. So you remember when I mentioned 9 GB of metadata overhead for the bucket cache. For the same use case, I estimate that the overhead is going to be like 640 MB for meta and all of Java heap. So it doesn't use Java heap at all for the meta information. Future, do we have some future roadmap? Yes, there is one more initiative which started recently. It's improving cache efficiency and stability for HBase and object storage. There is a RFC document. I posted link in the list. Get some initial feedback. So this is kind of definitely next big step if and when this pluggable cache architecture will be adopted and tested, and from experimental kind of feature will become the real feature. So the next move, potential move, is probably adapt Carrot Cache to distributed file system and provide HBase distributed, highly available and replicated cache service based on Carrot Cache on HDFS. This will give us continuously available performance when cache data survives region move, split, and reassignment. So in this case, currently HBase provides something like caches for that purpose, like mem cluster of memcache or Redis. But this is external system, so it just requires additional management efforts and resources, knowledge. It's not very easy to actually create a memcache cluster which is available, highly available, and replicated. So you need to use tools like memcache proxies or MC router and ask Facebook engineers actually how to do this correctly and properly. Besides this, actually, there are some very interesting stuff in this document, such as a caching composite, Hadoop compatible file system for fast cache refill. So this is one feature which allows, in theory, to mitigate the cache trash due to compactions. If you are interested, so just, I don't know how it says. I'm pretty sure that all this presentation will be shared with the community, yes, and there is a link for this document and this slide. So just please read it. It's, I hope it will be interesting reading. Thank you. And time for questions.
I have a question. So for all the performance scenarios that you have seen, has it always been the 64 KB block size?
No, it's a default block size. If you reduce block size to 32 kilobytes, your overhead will increase twice. So it's going to be like not 9 gigabyte, but 18 gigabyte, because you will increase number of blocks by factor of 2, yes.
Yeah.
And for some read optimized, point read optimized tables, definitely the smaller block, the better. Yeah. So if you don't do scan operations and you do only point read, so it doesn't make sense to read like 65 kilobytes of block just to extract like 100 bytes from this block.
Right.
So the general suggestion is just to reduce the block size. But when you reduce block size, you increase the memory overhead for the metadata.
Right. And even the IOPS, cost of the IOPS increase. Like if, say for example.
Yes, the cost of IOPS increase, yeah.
Smaller ODate for the RAM, 640 MB for 1.6 GB now. Was it like after compression, using compression?
No, so memory index, it's a hash table where the slots are references to the continuous blocks of memory. These blocks of memories, they have maximum size around 4 kilobyte, but they actually can grow and shrink between approximately 256 byte up to 4 kilobytes. And each block's memory has its slots. Number of slots defined by the hash. When you have a key, you hash the key, and by this hash table, you find this particular slot. Then you go to this continuous block of memory and find your particular index. Index has the fixed size. There is a different index format implementations. The size varies between 8 and 20 bytes. For the HBase and for this to replace bucket cache, we will need to add additional user data to this index index entry, which will keep hashed region name, like 8 byte, and hashed file name, like 4 bytes. It's additional 12 bytes. Like it's 12 plus 12 will give us 24 bytes. So basically, to keep one block or data block in this cache, we will need approximately 24 bytes of memory. And 24 multiplied by 25 million blocks for this particular use case will give us 640 megabyte, just to keep this index.
So third one.
Index doesn't keep keys. There is no keys at all. Keys can be very long. So all keys they are hashed, and we use some hash value basically. This when you keep hashes, not indexes, if your hash is very small, you will get pretty significant number of collisions, of course. So you need to choose the hash size large enough to minimize the collisions. But this is a cache, and collision in the cache means that you just occasionally, sometimes very rarely, just lose the data in the cache. It's not a storage, it's not database, it's not that important. For the default configuration for this memory index, collision probability is around 1 to 1 million. So basically, with a probability of 1 to 1 million, when you store data in the cache, you will not retrieve it back, basically. You can increase it. Everything is flexible, so you can write your own index format, which will use like 16 bytes for hashing. In this case, you will never see any collision at all, but you will increase, of course, the memory index size.
So when the region splits or the merges, how can the carrot cache because the blocks will be new, right? So any new query that comes, so there was this one of the point, right, which is like to provide the consistent performance even across the region movements and splits and merges. So for the splits and merges, is it like the new regions will get the previous regions blocks? Sorry.
This is we already talk about the future roadmap. Yes.
I see.
When we, I can explain this because it's very interesting. Let's consider the region move. When region move from region server 1 to region server 2, the system will quickly scan the memory index, and because every index entry contains the hash of the region, it can identify all the entries belonging to this particular region. It collects it into the one file, which is called memory index. I forgot this actually. It has a .mir extension. Memory region index, something like this one. So it collects all these entries which belong to this particular region into the single file and write this file into the distributed file system, which is a shareable and can be read by the region server 2. When region server 2 actually accepts the new region and it opens it, it loads this file from the file system, shared file system, and updates its own in-memory index with all the information, which is basically the operation is extremely fast, and it's estimated it will be done like in several hundred milliseconds.
Basically, it's just metadata. Great.
Yeah, it's a way of transferring metadata between region servers.
Yeah. Is this file only written when the region is being moved, or are you trying to keep it in sync with the memory? Because if the region server crashes, it's unable to write this file.
Yes, the case when a region server crashes, unfortunately, it won't work. I mean this approach, but there are some workarounds, and they definitely will be implemented. So for example, we can perform periodical update all this meta information in the file system, like snapshot, doing some periodic snapshot. And even in case of the crash, some data will be available when this crash restore will be executed across the cluster. And because it's a per region file, so any region server which will get the new region assigned will be able to load some data. Maybe it's stale data, of course, but majority of this data will be correct. So like most of the data will be correct. It's Yeah, this is basically it's a kind of fault tolerant approach. The general approach, I described it, relies on the fact that actually everything works as expected. If server crashes, yes, we need additional thing to implement.
That will be whatever the pluggable after you have the carrot cast integration, right?
Yes. It's I would say future several years from now, at least.
One thing I still don't, maybe I get that. You said that in the previous slides about this is an L2. So if people still want some portion of the memory part, how does it work like in the region server? Because I consider that could be a totally remote, remote, I would say use the file system as a backend, but then the in-memory part, how do you handle that?
So we can come back to this topology layer, so you can define the inclusive topology, and inclusive topology means that layer 2, which is basically which we can easily serialize and save, contains all the data in the cache, including the data from the L1.
Is that a sidecar of the processor in HBase, or like you have another agent running on the same host to do those?
No, it's inside HBase.
And the memory part may already, if let's say I call it flush, you don't do any snapshot of flush, then that part should be gone. The in-memory part might crashes.
Okay, can you actually?
So again, maybe I was thinking the way is the carrot cache implementation will have the L1 basically is a local RAM cache or whatever cache. We're not using SSD yet. So that part, if we have snapshots, then yes, you will already flush to L2, which is the backed by HDFS. But before that, I think it will be the same as current block cache implementation. Whatever loss in the memory, then it lost. It will not be.
You mean loss in the memory due to server crash?
Yeah, something like that.
So you're referring to the block cache, which is the in Java memory.
And loss, yes. Because unless I think this is the right mode, but I just described. Just like I think if there's any people don't want to warm up the cache again if you keep the memory portion not large enough. Let's say not much, like just 2 GB of the memory per host. But then
okay, let's first of all carrot cache. I don't think carrot cache will be used in the L1 layer.
Okay.
It's L2 definitely. For L1, HBase already has it.
And just keep using the block cache.
Yeah.
I see.
Then, as I said already, to mitigate server crashes and make it more fault tolerant, we will need to do some kind of periodic snapshots for this index structure. And index structure, it's basically, and if you use topology, which is the inclusive one, so inclusive means you have L1 cache in Java memory, L2 cache off-heap, for example, or on disk, which is powered by carrot cache. Inclusive topology means that all the data in the hard cache resides in this cache as well.
Right.
That means that all the data from here lives here as well. And if we do periodic snapshot of the memory index here, so we keep all the data basically. We save all the meta information. And then later, when it will be restored on the level L2.
Yes.
But later it can be propagated into level 1 if it's hot.
Yep.
It's again.
When you keep both the data in L1 and L2, you have a cost for maintaining the consistent, because then ultimately the data will flush to the disk. Because when you put this data into the right path, let's say I'm updating anything, I'm updating any key, so this L1 and L2 will be updated. It will not be flushed directly into the disk.
In case of inclusive topology, if you update data in, so you do not update data in the cache, probably, or if it's not the cache on the right. Okay, you can cache on the right. If it's inclusive topology, when you update a level 1, you next you update level 2 as well. Yeah, it's additional work. It needs to be done. But there are some upsides as well. So you don't need to promote or demote data from L1 to L2 because it's already in L2. So you need to decide, should I actually, if data is evicted from level 1, should I actually store it into level 2? No, you shouldn't. It's already there.
It's optimized for you. Before I start, like I'm the last one and we will have a discussion. I extend this room already, but like for folks in HubSpot, I didn't get an act say you guys have the room, but I assume yes. Okay, it's almost like full at your time. Is it okay?
Kicking us out.
I cannot hear you guys.
Nobody's kicking us out. We're all good.
Okay.
Over there.
All right, sorry for that. Then let me quickly do mine. Mine is a high level one, so it shouldn't take long. Then we can go to the discussions. All right, let's do it. So originally, I don't have one, but I know that folks didn't come, so we just talk about the KA story on our side and what we have done and what we plan to do forward. Although right now, like we are talking about priorities internally. All right. So let me go to the background. So actually, back to 2023, our team already presented the community of a code by Sergey, and like yeah, we were there. Sergey, me, Ankit, everyone was there. And then we presented the first version of how we build the HBase running on Kubernetes. I will capture some of them and then what we have before. So at that point, I think also even now, people still think Kubernetes is a solution for scalability. Overall, like after a few years, like they keep still doing this model. And then right now, a lot of, I think, Bloomberg is asking us, do we really support it like a SaaS model for them? But I know folks in teams in Salesforce, like, yes, Arista Network is doing that already. And then someone else in the community say they have done that also. So the good thing is like, yes, you have a Docker image, then you can do whatever cloud that you want. You don't have to think about anything. It should be as simple as like you have the compute and you have the storage that you do. But of course, the storage is a problem for us, not for the others. And then what they have is because, yes, Kubernetes, then always something went down, then you will have it back up by the policy that you define. And yeah, good thing. Like, but whether it have some issues, you don't know. That's our story as well. And always like someone drive us and another one, I don't want to name them, but like that user say, yeah, I expect back the TCO, but to be honest, I calculate the overall price of just the hardware and stuff and the instant money. No, you're going to pay more or less the same as like that. But where the TCO come from? It should be from the engineer side or the team that you build around those support those hardwares. So that part should be a smaller portion, but there's a assumption. The assumption is you have a team that actually have expert in those stuff. Oh, if you're not, then sorry, actually that TCO is not that good. All right, so I'm not back. Before I start the project, even now I cannot say I am an expert. So I covered some of them, but like the discussion was online. I mean, Nick also helped us already create some commit was there. I don't know whether he continued working on it, but the HBase like customized is there for building the image, but not the parts that we actually have. Each of our like I would say of the community, each of their own solutions. They have their own repos. Someone posted already. So there's the Helm chart part. They have the Go HBase that they built on the other side, but we cannot merge in HBase basically because we have different voices. So, but generally, we are following the same model. We are following the operator model, different operators. We have so this is what we have done. Next one. We have the same thinking of like, you need to build a lot of YAMLs. Like we call it Helm charts, but like YAMLs, bunch of YAMLs to do the deployment. This is not fun. Agentic deployment help us, but still not fun. Okay, you can find the syntax, but at the end you will hit the barrier whenever you deploy it, and then you find out actually just miss several parameters that you don't expect, like the environment variable, something like that. We do that. The image is the easiest part, not far away from we build parcels or build RPM or stuff. You just package in the content, like in the YAML of your container. But the thing is about permissions. Like a lot of time we find that like you set up a user doesn't match the Kubernetes users, and then cannot start, and then you find a permission error until you go deep into the logs of the CDL or whatever the chart tell you. So, but that part we still get over it. The other part is about like productionize is the like release of it. So releasing that is a little bit different. Like previously we will have our own like we call parcels, but let's think about RPM like S3 bucket that you post there. It's the same, but like after we post there, we have to maintain the chart one, but that will be something that like we use JFrog, but at the end, they are not the same endpoint, and you have to do something and then make it as an OCI compatible that people can use. But I know the community, someone want GitOps, like you use GitHub, faster like commit like reversion, but I think for enterprise, normally there's people use OCI because then you can have the auto recover from the previous working image, and you don't have to think about that. So that part is questionable for that. And then what we have done in the previous work is proposing using EFS. We actually, of course, EFS they have replications. So it should be also Unix POSIX like compatible, which means for the wall is okay, you can write and stuff. But we still have concern about that. HDFS overall is like counter that part and for considered as a much more resiliency. Like, and then EFS also have the burst mode like limitation, and you go beyond something, you cannot do it. Then our offline private cloud solutions have integrate with SAP-FS, and I don't know what they can do to be honest, but like I would say we still want a distributed storage, so we want containerized HDFS. We want containerized Ozone to support that. Although Ozone integrations still stuck with the wall like performance part of whatever they do. So we are working on it. The next one is about the operators. Operators, at the end, we decide at that like our previous work we already integrate with Fluxity first version, but we always make a wrong choice of doing Java development. In fact, actually, a lot of things can be easier if we choose Go at the beginning. We still use Java, but we have a better integration to call the Flux API to manage the pod cycle for us. So that has been done as well. And then the benchmark results so really bad. External connections because of our problems is if you are just like supporting your internal company, you have, let's say, using cloud, AWS VPC, or whatever way that you do with your own network setup, that we argue a lot with the community. The newest like way we think about using Istio is you think the network is open, you have a way to do the boundary, but in fact we are thinking to support as a service for as a SaaS solution, which is like you provide your software package then put to others and they use it. It's not that way. So we have to think about like how they access the KA cluster in a way, I don't know, like not the AWS way. AWS, I found it already. I do the POC. The VPC ENI can assign the same host name, like to the same IP address range to the same port. Although have some limitation, the ENI is like per host you may be running up to 16 IP address you can assign to that host. Depends on the instance type that you use behind the scene as a host for the Kubernetes host. But then that can do something already for you. However, we also have to support like private cloud. It's our mainstream or whatever we want to support. That one doesn't work. We have plugins, but we want to see if we don't use the plugin, can we access it like the way? So STO is the answer that we found with a lot of good reason. I think the surface mesh if we have it, but the problem is about HBase. HBase is using RPC. It don't have like gRPC support. They don't have the HTTP header support. The routing of a request, what we build for the proxy doesn't work very well. That's the performance part. And then also a lot of things in HBase logic. For example, single put, single get, no issues. But the problem is multi-put and multi-get. Our proxy internally, in fact, is rewriting the whole batch. And the performance slow down from there. The YCBS was so slow. Okay. The one thing here I skip is the authentication. I keep got asked from the user saying like, are we still using Kubernetes? And I'm like, yeah, I think most of us are still doing that. We have another approach in our offering is using Knox to issue the JWT token. We want to use that for even the RPC. But then to do that, like either the problem is about the next slide that I have is about the proxy. You cannot use JWT all the way when we have this like proxy stuff. For example, the client is using the JWT token talking to a proxy that we have. The load balancer is just like load balancing, but the proxy itself is a embedded like HBase you can consider as a region server or something like that. Like receive the request, we rewrite the request as an internal request back to the clusters. Why don't we just use the HBase REST API? It's because like we think like first previously we have another project called scan service. We're trying to maximize the scan like a REST API, and then we some kind open source some part of it, or like we publish that, but then we find out that like actually only specific user just want that use case. At the end, when we adapt it here, let's say scan like a REST proxy, it doesn't work. It's not REST first, it's RPC. So it kind of, even you scale up, you map whatever the region like location is. The problem is about the region location that you access, you cannot access. Then you have to reload from whatever you have from where every time you bring up a host, then you need to ask again. You're not caching it. So step out, slow it down first, and then you have to maintain your embedded, everything. So at the end, this complexity doesn't make the system fast enough. So that's why we try different stuff, and we were proposing the STO gateway, like with a port open for each of the region server, and then you talk to the STO, then you can go through it. People have different opinion, and then like Balash is the guy who helped us to drive this. Or we internally say, oh, it's okay, but propose to the community is that, yeah, maybe you can do differently. You can do a client implementation, have like the client understand the network instead of you have the server to handle the rewrite on the coprocessor level. So this is ongoing. I think he had the point in some way, because otherwise, in fact, internally we propose two different solutions. One is which is the STO with RPC level. The better way is with the gRPC that you don't have to think about that. The gRPC will have the embedded stuff in the client header, and then like go in, and things could be easier. So this is, we might give it another try, but if it doesn't work, we may just go directly on, sorry. So yeah, with the STO, this is a high level, looks like what we are trying to do. So we will have the client come back to the STO network, like STO network gateway, and then you have everything that you have for Kubernetes, and then we can go back to the regular route of HBase. And the problem here that we see also is about, I highlight the storage. So we actually are just the HBase team. We are not the storage team. So the problem is like making the performance good of like the ozone and HDFS within like the Kubernetes environment We don't have that knowledge, so we are trying to ask help to get that. Assuming we can get that, we still have some issue. It's about the locality. Like I think you guys, Salesforce folks, have already posted how you can make sure they are binding together. I know Kubernetes has a way, but still the downscale, and I think mostly it's a downscale part. You scale down the data node, then we even still lost the data locality or whatever. What can we do with that? I think we need some special treatment in either HDFS or in Kubernetes to make sure that you don't go down too much. So that's the problem of the storage. And related to the authentication part that I just described. So I think it's good. We actually already have MTLS in the community. We also have the JW token support that right now everyone can use. But then we want a straightforward one single thing. So if with the gRPC support, if we can, or find a way to make sure enhance the HTTP headers part, then actually we can do more than just like pulverize like support authentication. So yeah, but why gRPC? I think the mostly like reason is because we want to support Kubernetes like more easily. That is the main reason. Whenever we see the security alignment, like without it, we already have some workaround solutions. But what the challenge is, we actually, before Sergey worked in some other things, like he already worked on it. He had the gRPC branch in our downstream. However, we find a performance degradation of the byte buffer support. So it's not like, originally I thought he wrote a notes called like copy of the whatever byte buffer to back to in between the gRPC content is not there. And then you have to do more, because it's standard, then you need to copy the whole array of byte to another one before you send out as a response. In fact, there's some pieces in between could like skip some of those like byte copy. But you still need to have at least one, because like whenever you have those like fill out in the shell, in the shell, whatever people send out, you still need to copy it before you send out to the stream. That thing we actually haven't investigated, but I think that he called out as a main reason of, other than the extra gRPC header stuff, that 10% maybe, but this one will be causing us like even slower, like more than 2 times. So, but if we have that, I think the last round of, I think it was way back to 8 years ago, someone proposed it. Then he also hit that, but he went away. So if we have someone to work on it, then with gRPC, it will be a better security alignment as well as the performance. We fix it, then we can have a new version of how connection could be do. I think it could open up more things as well. So that's what we are, that 2 main issue is what we have today, like that we want. But other things we want as maybe as a really enterprise solutions is we find that like, especially the storage part is not yet there. And we keep saying we want to get away from one of the HDFS mainly. We talked to the Ozone team. With the Ozone team, have any thinking of how to improve the write-ahead log performance? What they found was actually whenever you write, you need to find out the replication act chain. So that part become, in fact, it's just a metadata thing other than the data block. But that act chain slow down the entire sequence of how fast the append edit could be done. So we want I talked to one of the major lead in there saying, if actually they are solving that problem right now, they are trying to use the erase code logic to not let the client decide whether this is the right act. Instead of, you have to go back to us also the leader of this is if my block is already append. But that will be maybe save them at least like 2 hops of asking the leader, where am I blocked? Is it okay? Something like that. So if they solve the problem and they are also have solved then the write is okay, no matter it's remote. However, the read path of short circuit read and the data locality path remain the same. Yeah. So that will be my presentation for K8s. So any questions?
And do put a suggestion in the chat.
Yeah, we have a comment.
Oh, sorry. Can you read that? Like,
Maybe we can patch GRPC. Sorry.
Oh.
Go ahead, Andy.
I could just say it, which is maybe you'll be able to patch gRPC the same way we've been patching protobuf source and recompiling it before shading it into third party to avoid the byte copies.
Yeah. I don't know whether Suki consider this, but this is a good point.
We didn't really want to do this with protobuf either, but it was, philosophically, the protobuf, the Google developers, let's just call it, were, immutability and other things, right? Like the copying is part of the contract is safer than the alternatives, and it's undoubtedly true, but also not good for performance, right? We have a route to avoid byte copies with gRPC, but you can always hack one in since we have to shade it into third party anyway. So not unreasonable, yeah. Just it feels unclean, but it's a practical solution, for what it's worth.
Oh, do you mind providing context on how, if we use host networking level on the region server pods, what would the challenges be? And maybe you can provide context on why it's not in the list of proposed approaches.
So let me go back to my slides one moment. So the reason, let me see if I can share my screen again. One moment. So in this context of the graph, you can see the actual master and the region server are inside the Kubernetes network. Then they will have a internal host name. So, but like the client itself, we are assuming that the client do not have the same Kubernetes host name because it's not part of the Kubernetes network.
Right, but if you're using host networking, then the region server will get the host name of the kubelet.
Yes, but I'm saying that how about the client? The client is not part of the DNS.
True, right? But then when you get the the region server list, right? You get the host name of the kubelet which hosts region server number 1, right? I think last time I configured the region server to have the point bind to 0. So it gets a random high port with host networking. I don't remember the client behavior, but at least the UI of the active HMaster cannot get the random high port because it seems to need to be explicitly defined.
No, because I remember we actually, so yeah, I'll say this way. Each port normally will be assigning a host name. And then yes, it's -0, -1, -2, -3. And then that didn't change. If the same region server come back up with a different IP, we still have the same DNS host name. But what I'm saying is, this is fixed. However, I'm saying the client itself, when it come in to find that particular region server, without the STO thinking of a port mapping to it, you basically don't have network access to the Kubernetes thing. And if you are saying
right, so what I'm saying is you skip the STO part, and then so the client accesses the host port, because you're using host networking of the region server pods.
Oh, you mean no port?
Right.
Is that what it is?
Like host networking, right? So basically, you skip the entire Kubernetes internal networking, and basically the pod sees the entire host's network stack.
I think in our community proposal, we did mention about there is another approach of no port, and then you skip and then directly talk to that port. But that is a drawback of
Like I think, Node port I think still uses IP tables behind the scenes, so it's there is still some like disconnection over there. But if you use like basically host networking, right? You skip the entire container networking stack and you use the host.
How can maybe I go back to check? Then there is a mapping between the region server port to the host port that you talk about. DNS.
Yes, yeah. So basically, region server 1 will get host name 1, and then when you say, like, for example, I think 1600, the default port, right? Then it will also allocate 1600 on the host machine, because it's the container networking gets skipped with host
And
level.
you have then doesn't it having the same? You cannot only have one region server per the Kubernetes host.
Yes, right. So one way to tackle it is
we don't want. We want to use the native Kubernetes way. The reason what you talk makes sense. It's just like we want maybe some region server on the same host.
yes. So like
By the host.
the one thing is like you can set the bind to port 0, so it goes to a random port.
Right. Then how does the HBase know? Sorry, the client know the port is different.
Right, because like if you use 0, right? So I think I opened a Jira years ago. Like the random high port that's being acquired is not being registered. I think I only raised it in the UI. I can't remember if the client detects it.
Right. You're on the UI, you're right, but on the client we don't know. Yeah.
Right. So like, it's a registration thing that we can fix in the region server, right? Like instead of looking at a hardwired port in the config, right? Whatever random port it acquires, it should register to the
meta table.
Yeah, the meta table. Yeah.
I'll just add what we do at HubSpot. Is like we also, ran into the same issues here. All of our infrastructure where an HBase client might be running, or anything that's a client of something in Kubernetes, has like some special network routing on it. I don't really understand the details, but if you resolve a host name to an IP that like belongs to our Kubernetes like IP range, then like all your traffic goes into some like special bridge so that it's like you were inside the Kubernetes.
Right. That's what the ENI of the AWS is doing, right?
Okay. So that way, like, and that's not that that's an easy thing to set up necessarily, but that's another, if you do that instead, then you don't need any of this. Yeah.
Cool, thank you. Let me see if there's any more questions. If not, then I will.
What is that Go processor that you have mentioned in the slide number 9?
Where? Sorry.
Slide number 9. Next.
Number 9. So what we does also was, yes, it still is like, yeah, your port has the internal host name and IP, but actually we map it into it's still gateway port with the public like host name. So then whenever we we want to connect through that, we will say like these port recognized by the region server as in the processor level that when we request come in as an external host name with this port, we will rewrite it into the internal understandable by Kubernetes, which is like default HBase understand. I think that thing got really not like accepted by Duo.
Yeah.
And he's the only guy reviewing it at the point. Yeah. So that
is
is
there any performance impact?
for this one, I would say the just about the host name, I don't think it's that much. Yeah. Because it's just coprocessor.
Yeah. Okay. Makes sense.
It depends. I think everyone in Kubernetes is using it still right now. So okay. Oh, sorry. I will close this with the discussions. One moment. Let me see. All right. Let me go back to another one. I think I just make it up, not limited, or even you have your own mindset of what discussion you want to discuss. We can talk about that. But yeah, open discussion right now. Because I feel like last time the meetup was 2023, we asked similar questions, but we haven't moved a lot. At that part, I thought 3.0 is almost done, but now I think it's still almost done. Theo said just few more sanity check and he will be able to do the beta too. So I guess it's better as shape right now. We have a lot of stuff, but then what next? Is our questions like co-highlight of what are the new feature or what are the major change. So I from my side understanding there's something that I wrote, but maybe I think your DynamoDB connector make change of HBase using. I mean, you make Phoenix supporting document DB or even different thing would be a good sign of like you may drive a lot of innovation in HBase to support different type of use cases, and then we'll be changing what HBase can store. Yeah.
What is the is there anyone using MTLS authentication in production?
We have one customer is using it.
HubSpot's using it.
Yes. I see. Yeah, HubSpot drive it actually.
Yeah. It's kind of like we have our own certificate authority service that has integrated into our like authorization system that's knows about, you know, what your job is here and all sorts of corporate stuff like that. So it probably, I wouldn't say it's trivial. It's like you don't have that infrastructure already.
Right. It certifies that this agent server is running on this. And
well, right.
It gives the certificate, you just trust
right.
the agent making that.
Well, and like in terms of the region server authenticates the client's identity. That's okay. That's the trickier part, because like what is it attesting to? And like if you have a fancy certificate authority service, then the existence of a certificate can attest to like fancy things, like you work for the HBase team, for example, and you're not like, you know, an accountant, right. And stuff like that. And that's like, yeah, that's where it's like needs a bunch of extra infrastructure.
Are these like SPIFFE certs, style certs, or you have a different your own?
They're delivered as like JKS files.
Oh, okay.
So I don't know.
right. But you don't. What infrastructure issues it is paid to you?
Our KA first like version, in fact, using the MTRS in between the port as well. Yeah. And then we sure everything.
Maybe not in JKS, but maybe there's a region.
I have a question. So I think it's HubSpot or maybe we're using quota in production, right? And HBase quota, RPC quotas. For throttle, I think it's HubSpot. I think I remember I saw.
We have some user used RPC quota. I don't know. Did you guys use it? Like
yeah,
we use throttles.
So do you see any like performance impact of it? Like when, as the traffic increases, is it like how much is the load on the, quota meta table, or what should one consider before, starting using it on an existing cluster? Any recommendation?
We did run into issues with this.
But it's fixed.
Charles fixed it. However, we also introduced like table isolation with some balancer changes. And so we can basically isolate, like importantly for us is, like if a quota table runs hot, you just won't be able to update, the region servers that have to apply these throttles, may struggle to like asynchronously update their cache of what the throttles are. But it doesn't actually interfere with user traffic, which is like what's important to us. So we isolate the quota table onto its own region server, so that, if there's any hotspotting to that table, it doesn't also impact the rest of the traffic on the cluster. But it was a lot more problematic in the past, and now, Charles, you fixed that, right?
Yeah, I changed the logic of how the quota cache refresher refetches quotas from the quota table, so it's one scan instead of many gets now, which is easier on the database. One other thing about enabling quotas is it's not completely free to send a quota exceeded exception to a client. So you actually do burn CPU cycles declining to service a request, which occasionally we've actually still gotten servers overloaded just because they're sending so many denies. Yeah.
Yeah.
Is HubSpot distribution CPU utilization is sensitive? How large the maximum you see normally per day?
It varies. I would say we currently don't. Maybe the reason we don't really know exactly is because we haven't had many issues recently. But on our higher priority tables, we're fairly latency sensitive, and any slowdowns, even for a period of a minute, is pretty impactful to the product.
I mean, we're not that CPU constrained currently. We were in other years, but AWS keeps giving us better and better instance types. So the CPUs keep getting faster, but the memory doesn't get any larger. So now we're memory constrained.
Yeah, the memory part, we have a magic here, but we're trying to change that. It's related to JDK, GC. Previously, we always set the maximum we can support in the cloud is 41 GB because of the GC metadata issue. But then I think I keep researching 2117 wherever JDK actually has not that issue anymore. I think we need to revisit the number, how large the research could be. Yeah. There's a lot of other guys saying in my on-premise old days, I can set up a bigger and bigger instance. Why not in the cloud? We can't keep getting someone say want storage tiering for cost optimization. Do you guys see the same? Because
sorry, what?
Someone always reading the recent data. That's the main issue. They were thinking what if we can save some cost moving a lot of stuff to S3, and then for the regular data, they read last 7 days, let's say, to read from HDFS, and then maybe the critical one that using more cache to store them. So that will be the model they want, not just what we propose all the time as just raw on HDFS and then data on S3 with ephemeral cache, bigger cache, a lot of cache. That's why we have the other project as well.
Yeah. Makes
Like,
sense.
but like,
We,
what do you guys think?
we don't do anything different to every one of our clusters. The cache tiering is set up exactly the same. We have, we have the like normal cache in the heap that's like the level 1 cache, and then we have the the bucket cache off-heap. But we do tiering, and then also for our like on disk storage, it's always HDFS. Every cluster is HDFS. But then we tier based on like what EC2 instance type we pick. Like the fastest ones are IAG, and the like cheapest per storage byte is D3. And like that's enough of a lever that we can adjust to change the price like per byte. And then also erasure coding, we turn that on sometimes.
It's a different approach, but like, yeah, that doesn't satisfy the guys who want to use the cloud storage for us.
Right.
Yeah, I don't think we could get any of our client teams on board with the trade-offs of cold storage, sadly.
Yeah. All right. Any other more questions?
Maybe
Sorry.
more. Start over. Oh, is there a question? Sorry.
No, I just.
Oh, yeah. Sorry. Can you hear me?
Yes.
So, are we thinking of also reducing dependence on Zookeeper as part
We
of
already
maybe?
did, doesn't it? Like
Yeah,
the
yeah.
master,
That's,
whatever thing in 3.0.
Okay. All right. So we
Yeah,
don't
we
necessarily.
actually want that one to be away because like I remember is one of our proposal recently, right? From Wellington also say like less Zookeeper state and then everything into the master region that we have in the upstream.
What's the strategic plan? Do you reduce the dependency or get rid of it completely?
Sorry, Andor is the Zookeeper PMC. So maybe what is the concern about Zookeeper? Sorry, yeah.
In our case, the dependency is a problem because if we had to depend on, say, for example, our own Zookeeper ensemble, which we have been pushed to do in the future, then it becomes one more dependency to take track. If everything is self-contained within HBase, it reduces the dependence on these kind of external systems.
Is it just the maintenance burden?
Yes, the maintenance burden. And to be able to track and monitor another system, essentially, right? If Zookeeper goes down, then it has like ripple effects, right? Same thing with, I think, Kerberos, we have a big dependency on AD. And if AD for some reason goes down, which has happened with the CrowdStrike incident, it brings down our entire system. So maybe reducing that dependency also helps with stability as well and resilience.
Yeah, I think that's understandable, but the Hadoop philosophy is having or outsourcing these services into different components, and just reducing these dependency is going the other way. I understand the reasons, but that's maybe against the original principle.
I see. Okay, I was just curious about that.
I mean, but from the HBase community point of view, we have done a lot of work. You know that, right? The master region thing.
The master region thing is a pretty cool one. So it's you don't have to configure the client to know about the Zookeeper nodes. It's pretty cool. But storing data in Zookeeper, it's not the end of the world, I think. You also you have to maintain HDFS, you have to maintain Kerberos stuff. So yeah, obviously you have to do the maintenance and the monitoring for the Zookeeper ensemble. Yeah, that's the cost.
And then you now have to maintain a stateful HBase. It's a different operation.
Yeah, I guess the responsibility has to be maintained somewhere, I guess.
Based on our, sorry, one more thing. Based on our experience at Cloudera, yes, we have to monitor and maintain the Zookeeper ensemble, but the errors or the issues reported, or we don't see anything like that. So basically, that's mainly any escalation or customer issues reported by Zookeeper is 99% user error. So we don't see too many bugs. We don't see any issues basically with the Zookeeper ensembles. They are pretty stable. All customers have to keep monitoring, that's for sure, but no issues or no anything which affects the cluster seriously experienced. So it's pretty stable, I can say.
I think more is from the versions that they need to maintain over time. It's the same as others. Like you have one more thing to taking care of, they need to
That's
they need to have
fine. But I think it's less of a headache.
I think we have not seen issues with Cloudera, so it's not to kind of indicate that there was problems with the Zookeeper deployment from Cloudera, but rather there is a competing solution internally that we have at Bloomberg, and if we had to use that, we have been, in general, there's been this push to use that as a common Zookeeper kind of solution across the company. So it's only within Bloomberg that it's a concern, really. I wouldn't say it's a concern outside of Bloomberg. One other question I had was more related again to another problem we have, where we are completely on-prem and we use physical infrastructure. And the data is kind of currently split between two different data centers for data resiliency purposes. And every 6 months or so, we basically bring down one side to make sure that our systems are resilient, right? Data center resilient. As part of that, the problem is for each of our tenants, they have to actually write data to both sides, to both of the data centers, and they have to keep them consistent. Does anyone else in this group have the same problem? Like, do you have to maintain copies of data, consistent copies across data centers? And how do you solve them? How do you solve this problem?
Do you write to both clusters from the same?
Yeah, we have application teams have to manage dual writes.
Yeah. The tenants are tenants. So we are basically the platform owners, and then our tenants are responsible to dual write. So is there a solution like for managed replication that could be introduced essentially?
Are you using replication for this?
No, I think Read Replica is the one solution, right, for HBase.
So if you have to make sure you have one or two clients simultaneously writing to two classes, make sure data exists on both sides. Yeah, replication and also is one way I was thinking. So
yeah. So if we use something like NiFi, which is for kind of asynchronous kind of syncing, then that might not work because we need data to be in sync and HA essentially, right, as close as possible and strongly consistent as much as possible within a cluster as well. So we couldn't find a solution that is kind of available out of the box.
We actually don't. But I remember before Pinterest went away, they do more other than just replications, doing region replications. That was the only one I think of very close. Otherwise, how come you have another set of data? So, but how come region replica become your solution? Because that means we only have one single data. Are you saying you're using some other technology to synchronize or snapshot once your only copy to some other place? So the point is like, do you really need to copy of your data?
Well, we need to have, like I mentioned, for the DR purpose, right? We need to bring down a particular side every 6 months and make sure that the other side is completely able to satisfy all the workflows.
So we need 2 copies.
So we need to necessarily
the
need
same
that.
copy in both places.
Right. I think replication.
Yeah, I think one of our customers is using active replication
Yes.
for this kind of purpose.
Right.
But it must be synchronous.
Right. So active replication pushes the replication management to HBase itself instead of the
I don't
application.
know. We need to check it every day, you know. Someone in our room asked, is that like only that period of time, let's say closer to 6 months, let's say month 5, you start checking whether the data is in sync, or like you have to check it every single request?
Well, the expectation is that your DR at all points. The tests happen every 6 months, but the goal is that your DR at any point of time.
Yeah, active is the only.
It's a regulatory thing as well for us, being a kind of financial services company. Anyways, I just want to put it out there to see if there is any solution that the community has which we could leverage. Happy to chat later. I don't want to take everyone's time on this. There's other
You can
things.
put up a discussion thread and I maybe ask again for folks who's not here. Right.
Thanks for organizing this, Steven.
Yep, I'm moving to the last one. So thank you everyone for joining. I didn't say special thanks to TwoSide, but yes, special thanks to the HubSpot arrangement and also Salesforce guy, like also Cohen, lots of other guys online calling as well. Thank you everyone.